Okay, where did sync go? Stupid Vim. Whoa! There it is, sync. Okay, so what we were doing while we didn't have any network, we had, every time we had a catch, we would go ahead and store the catch with the rest of the catches. We would create a temporary ID, and then we would store that temporary ID in our own, what do you want to call it? But created IDs array, basically. So then when we end up hitting service, it's literally just creating that array of catches to create, and then we iterate through the current catches. We go ahead and rebuild those catches, and then we just make a bulk request to the server. Yeah, you can clap. That's pretty good. Yeah. Thanks. Thank you. Yeah, so we've got like 33 lines of JavaScript here, and that's literally the only thing that we had to add in order to support users being able to add catches offline, which I think is pretty cool. I don't remember what I wrote after that. I mean, we're kind of there. We do have a graph here. Yeah. And I'm kind of trying to spare you guys from this unless you want to start going through some of those. But I think the cool thing to highlight is just the ability to use catches offline by using a persisted store. And I can kind of walk through that here with create. So basically all of your updates are the same. We're just checking, we go through here, you log a catch. We optimistically create that catch. And we go ahead and set it so that the UI updates. And then if there's no network, we're going to add a temp ID to the created IDs, and then update storage with that. These separate ID arrays, all they do is track while your client is in control, which IDs do we need to then go through and use to update what's on the network. And same for delete. And then we have update storage. And the cool thing, so basically every time that we add one of these catches or delete a catch, all we're doing is writing to the local store on the device, which is effectively the same thing as local storage in a browser. The cool thing about mobile is on mobile, you're really worried about one device. You're not worried about 20 different browsers, not having to try and sync because this time they open Safari, that time they open Firefox. So you're trying to reconcile information. You just don't have that headache on mobile. And I think there's a lot of user flows where everything is so targeted towards your individual user that you don't actually have to worry about conflicts. Like, this is a great use case. These catches are something that I'm creating, I'm updating. Nobody else is updating or creating anything, so you don't even have conflict resolution, really. And yeah, I just feel like we're overcomplicating a lot of it, and that's my talk. The graph? I mean, we can do it questions. You want to walk through it? What? I don't want to show you the graph. What's up?
Why are you showing us stuff like this at HTMX conference?
I thought this was ReactConf. No, I think there's a lot of validity and there's a lot of use cases where something like this, local first, works really well with small composable pieces, and then you also have the HTMX side of things. Like say I have a feed of users where it really depends on real time. I need everybody's updates instantly. Like my tweet feed. If I'm refreshing my tweet feed, I want to be able to see what's happening right now. I don't really want to worry about caching, persisting, all that conflict resolution. So I think that's a great use case for something like HTMX. And then I think you have other aspects of applications where it really can be local first because you're the only one actually updating any of the information. So, you're just going to keep asking questions? What? Yeah. So, if we're out fishing, deleting a catch. Actually, it's too small. I don't want my friends to find out, right? So we're going to delete that one. So what we can go ahead and do is optimistically remove catch from catches, store it as a temp. So that's reflected in our UI. There's no new changes. We didn't have to show spinners or anything like that. And then we're going to check, is there a network? No. Does the ID exist in created IDs? No. Then we're going to add the ID to the deleted ID. So if we don't have network, this is where we funnel everything to that updated, persisted local storage. Otherwise, if we do have network, we can go ahead and make our optimistic updates, which optimistic updates work here anyways. We're already set up for it, so it's like that's already implemented in tons of UIs as is. So we're not really changing anything. Really, the only thing changing is the sync. Because we go through here, we make a delete request, did it succeed? Yes, then we're gonna go ahead and update our persisted storage, and then we're gonna go back to just fishing. No, we add the deleted ID back to catches, return the failed update ID caller for toast, retry, show the toast. If the user presses it, then we go ahead and show that toast, and we'll open the modal and pre-populate it with the catch that they were trying to delete. Yeah. And the syncing catches, that's pretty simple too. It's really just, if you're offline, you have no network, you regain network, you want to go ahead and check those locally persisted, created delete IDs, and then you go ahead and make your batch updates. And since these catches only pertain to me as a user, I can go ahead and make those changes without having to worry about conflict resolution. And once that's finished, we go ahead, so it's down here at the bottom. We go ahead and we reset the created IDs, the deleted IDs, and we actually go ahead and set fetch status to unfetched. And what that's going to do is just coming over here, we just have a use effect listening for, oh, not that one, screen. Neovim, by the way. Also blue loco thing, no big deal. So this use effect, all it does is it just checks if the fetch status is set to unfetched, and it goes ahead and kicks off that get request. So you can see at the end where, in the end of the sync function in the sync store, where that's being fired off, just by setting the fetch status back. Because they're local, even though we go through and make the updates, it can be nice to go ahead and just fetch the data, because occasionally things can go wrong. They shouldn't. But if they do, it's not a bad idea to go ahead and just refetch that data right there and then. So
is this you who updates the fish, or Carson updates the fish and the primagen also?
Oh, if you're talking about multiple devices? Correct. Right. So I think that starts getting a little bit trickier when it comes to updates. But for create, it's really not an issue because your device is either offline or online. And then say Carson is offline, so the client there is his single source of truth. Whereas Michael or primagen, damn it, docs, my bad, is say he's online and he's making catches. He's going through and hitting the server directly. But there's no real sync issues with create because you are on that device and you're just pushing up his catches, if that makes sense.
Right, because there can be a scenario where some session, he decides to update the size of Carsten's stick, and this is getting super weird. Super weird. I don't know if I can conversation anymore.
Yeah. No, that can definitely happen. Yeah. With updates, I think you just need to be methodical about how you approach it. Like, there's certain aspects, and I think you can build this in a composable way, kind of like what's built here, to where you could handle your creates in one way. You could handle your updates in a different way. Like, say I'm offline, now update maybe is disabled. But I think that was kind of the overall premise is you can break these things down into smaller pieces that really aren't that complicated and tailor fit them to whatever your use case is, if that makes sense. So, thanks.
All right.
Thanks, guys. What?
Well, I don't know if you know this, but we have a couch on here. This isn't just decorations. I don't know if you know this. We actually intentionally had a couch on there because people are going to talk. We have Kent, Carson, and Warren. And Kent, you're going to be in the middle. You got a lot of couch, a lot of seat to explore. You got a lot of space, so feel free to get comfortable. You can lay down if you want to.
Do I need to turn this on? That's on?
Yeah.
I'm gonna sit closer to Carson.
Test.
I would
You gotta
sit
sit in the
closer to
middle.
Carson too.
You sit on the crack.
Yeah, sit on the crack. I'm gonna let you guys do what you need to do.
And you have to
Okay.
face directly forward.
Nope.
We have yours off.
Okay.
Test.
I'll do
All
whatever
good?
you say, Carson. You are the actual
Yep,
CEO.
that's right.
of
At
an
HTMX Con here. Okay. So this is something that Warren and I have been working on for a while now. It's an idea. It's more of a concept. More of a concept than working on it.
Sure.
More of talking about
He
it.
keeps asking
am
me if
so
I'll do it, and I say,
terrified.
okay,
Yeah.
basically.
Okay. Do you want to start or do you want me to start?
Start what?
I don't know.
Okay.
Okay. Is it Ken or Kent?
Kent.
Kent. Okay, Ken. So what? How old are you?
35?
Do you regret that?
No,
You don't regret that. Why not?
because I've had 35 awesome years.
35 awesome years. Where?
Not one bad year?
One bad one? Any bad years?
Not one?
Oh, every
19?
every year has been good.
That seems unrealistic to me.
I don't know what to tell you, man.
I'm almost 50. I've had some bad years.
2020 was rough,
2020 was rough.
but it was also the year that I launched Epic React and made a ton of money.
Okay. Do you like money?
Do you not like money?
I love money.
Yeah,
hate money.
same.
Warren, how do you feel about money?
I hate money.
Money's the worst.
That makes a lot of sense. That checks out. Yeah.
Yeah. I know why I hate money. Why do you hate money?
What, do I hate money?
Yeah.
I don't have it.
Yeah, I know. It's the worst.
Yeah.
Other people have all this money and I don't have I
It's
hate
not
it.
fair.
It isn't fair.
Can I have some of yours?
Do you have a lot of money, Ken?
Can I have your
I
money?
have a lot is relative. I have more than some and less than others.
Yeah.
I don't
that's
need
true.
much.
Yeah.
Let's talk later.
We're talking right now, though.
Let's just make like a
This is
verbal
perfect.
commitment.
It's the perfect time to talk about money, I feel like. Like, if
Okay.
I was going to talk about money, this is the time that I would do it.
I have some yard work I need done.
Oh, I don't want to work
No,
for it.
that sounds like, no.
Oh,
I don't know about that.
that also checks out. Yeah.
I don't know about that. Okay.
What size shoes do you wear?
9.5.
Damn it.
Why?
You like my shoes?
They're too
No,
small.
why do you wear that size?
Oh.
That's the size of my feet.
Is it?
I think so. But now I'm starting to question everything. Like, why did I come up here?
If React were a type of cheese, what kind of cheese would it be?
Mozzarella.
No. Shut
Easy.
up. Shut up.
Easy.
Shut up. We talked about this, Warren.
It's provolone.
Provolone, okay.
That's-
Why?
Because that's my favorite type of cheese.
And you would say React is your favorite kind
Yeah.
of cheese?
Yeah, it is.
Okay. What about HTMX? If HTMX was a cheese?
Blue
cheese.
Because I hate blue cheese.
That is messed up, man. I'm sitting right here. He's sitting right
I love
here.
blue cheese.
How do you feel about, what would you, native something?
What?
Local first?
Local first.
That was HTMX native.
Why
Yeah.
would you do that?
I don't know.
Right here in front of all my fans?
I don't know if they even like you. Do you know?
I don't even know what it is, really.
I honestly already kind of hate the word.
Yeah, I don't think you know what it is either.
No.
Does Ken know what it is? I don't know.
I think I missed what you said. Are you saying native? You don't know?
Is it native? React Native?
Oh, that one?
What is that?
That's a thing.
Okay. Tell me more.
You use it.
You use it?
Yeah.
Okay, for
builds
stuff.
apps.
HTMX is a thing too, and you use that too. That seemed different. You were talking about there not being a network.
I can't. What's he getting at?
I think that he's just mad because HTMX can't do what you were doing.
No. No. I just want to hear about this no network thing.
Yeah, you don't need
Because here in Montana, we have cell phone coverage everywhere.
privilege.
I mean, it's, so I don't understand that. I'm trying to get my head around a world where you don't have network connectivity.
Sometimes the phone no worky.
That's true.
Apparently, you haven't gone fishing because you
There's no
lose
service.
the network connection without.
Don't do that. That hurts.
I found his allergy.
No, it's all good. It's cool. I caught a big stick, according to Warren.
Yeah.
Or something. I don't know.
144
that got super
inches?
weird. That got real weird, in exactly the way I expected. So, how long have you been programming in Provolone?
Since end of 2015.
2015. That's
Yeah.
pretty early, right?
Why that year?
Relatively. I was like a year or two after Ryan,
Okay.
who was like one of the first.
One of the first.
One of the first, pretty soon after it came out.
Okay. Okay. How long have you been programming in blue cheese? Have you ever eaten blue cheese?
I've eaten blue cheese.
Yeah.
I haven't.
I'm not sure I like the look on your face.
I've not done a hello world in HTMX yet
Okay. Why not?
because I can do everything I want to do in React.
It's probably true. Warren, hey Warren, you're good. Warren, I'm sorry I'm boring you. Would you like to ask a question?
No.
No. Yeah. Typical. Okay.
Why don't we ask Warren questions?
Let's not do that.
He's just not that interesting at the end of the day is what it boils down to. Yeah, I feel like I've got Warren figured out, and it's, make your wife cut the lawn. That's like number one.
Yeah, I've seen this.
That was number one.
It's easier.
Real bad takes on pretty much everything.
Yeah.
I'm pretty sure that's mostly baiting.
Yeah.
'Cause he wants some of that sweet X cash. You do like money.
I don't like money.
No. He's pretty bad
Those
at I don't know. Okay, show of hands. How many people here think he's good at X?
It's so over.
Does anyone know X? Yeah, Twitter. Come on, let's be real. How many people here think Ken is good at X? How many people here think I'm good at X? Okay, why am I
Put
good
your
at
hands
X?
down.
What makes me good about it? Like, I don't know.
You're on your home turf.
I mean, it is my home turf. But
Everybody come to Montana and I'll take a vote.
Yeah, look at me, one guy. I don't understand that because Warren is so much funnier than me, and yet somehow people are like, "Oh, you're so good at X."
I
I'm like,
discovered today that Warren has access to the HTMX account, so I don't know.
he has
if
access to
is
way
it-
more than that. Do you guys know that? Way more.
I can get into anything I want to.
I know.
Yeah.
That is
We
terrible.
know the background here. We know the background story. Okay,
Why
let's
is there
get
a
back to
plant?
our guest. Why is there a plant here? I don't know.
It's not real.
I don't know if it's real or not. If HTMX were a plant, what kind of plant would HTMX be?
Oh, shoot. Morning Glory.
Morning glory. I love it. My favorite
cannot
plant.
I don't know what that
Get it
looks
out
like.
of my yard.
Yeah, exactly.
as hard as I try.
Exactly. Exactly. Ivy is the only other acceptable answer. Just a horrible plant. If React, let's see. How do you feel about Vue? Can I ask about Vue?
Yeah, sure. You can ask about
Yeah.
Vue. Yeah,
You like Vue?
I like that people like Vue.
You like? I like that.
It's kind of skirting around the question.
You think so?
I think so.
You think he's skirting?
What do you not like about Vue?
Template DSLs,
Okay.
Template. What does that mean?
domain specific language.
I know what DSL means.
So
What is?
Of course you do.
What is template? No, I don't know what a template DSL is.
Well, so the
Is this like
yeah, it's
know what it is,
HTMX
but
is got the same
JSX?
thing. You've got a template
Yeah.
that is specific to this domain.
okay?
And so I have battle scars from AngularJS. That's
Okay.
my problem. And so I invested a bunch of time and effort into understanding Angular.
Yeah.
And then I went on to React, and I left all that knowledge behind. And with React, I spend an afternoon learning about JSX and how that compiles into JavaScript.
Yeah.
Now everything else I'm learning is JavaScript.
Okay.
And so even if I move on from React, I can keep that knowledge with me.
I'm sympathetic because I invested a lot of time in not learning Angular. And so, I'm also angry about Angular. I feel like we're both angry about that.
All
You
right.
seem like a pretty angry. You seem like a pretty angry guy.
Yes.
Yeah.
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 You
Always
got
hot
me.
takes.
Yeah.
This is good, by the way.
That's what
It's
I.
like a hot take.
That's what I see on Twitter. Is a lot of anger.
Yeah.
Yeah, it's festering.
Is it?
Yeah, you don't want to see this come out. Have you ever seen
He's turning
Naruto?
green.
That
Naruto?
fox, that internal fox?
I feel like I should know what that means,
No.
but I don't.
Okay.
Do you do any mixed martial arts?
No.
We probably should ask that first. No?
No,
we're
I
fine.
don't.
Keep going. Sorry.
Yeah. No. I think
But my kid is a white belt. She started last week.
How many kids do you have?
5.
5.
let's
Which one's
go.
your favorite?
Which one's
Come
my
on,
favorite?
get it up. 5 kids? You kidding me?
I-
Clap, please.
5 kids. Woo! I'll transfer all those claps to my wife.
Yeah.
Who did all the work.
I don't know. Not all of it.
But yeah. I mean, that's just biology.
Okay, we're getting weird again. We're gonna stop. Getting weird again. If warm buffering were a plant,
Ooh,
what plant would he? He's
I know this
massive.
one.
He's a big guy.
I know this one.
I want to hear what you.
You can't choose your own plant,
Yeah. Oh,
Ken. Can't choose your own plant.
Warren buffering is a sunflower.
wow.
I've seen some big sunflowers, so
They do get tall.
yeah, they get
Yeah,
big.
sunflower seeds are delicious.
Yeah.
And they face the sun, big
And
outside.
they kind of like
Face
wilt.
the sun. Yes, exactly. That's what. I
Look
was
right
thinking.
into the sun.
Yes.
That's
You've
Okay,
seen that image
I'll buy it.
of the eclipse years ago, and Trump staring straight at the sun when everybody was told not to look at the
That's
sun.
me.
Yes, exactly.
Perfect. What's the meanest thing, Ken, that you could say about Prime?
ooh.
Prime.
He's the guy that's been coming up here and talking in between speakers.
That may have been the meanest thing you could have said. I don't know. I like Prime a lot.
Yeah.
Some of his takes are wrong.
Is that the meanest thing you can say about Prime?
No.
Okay.
No. He has wrong takes. What? No.
I can't. I'm gonna be. We're good.
Prime has wrong takes.
Okay.
Occasionally.
Bad
Oh,
takes?
here you go. I found out that Prime reinvented Falcor. He probably that's a pretty good one.
I'm
Okay.
actually building it now.
You are now?
Yeah.
Yeah. You do it right though.
Yeah.
He screwed it up, but
He did.
You'll do it.
It
You'll
was
do
right
it.
there.
I mean, look at him.
Yeah.
Stupid mustache.
I like it.
What are we doing? Come on, man.
So if you had to write code in a different programming language,
Okay, so here's the thing. I have written in PHP, Go, Perl, and Java, but you add up all of those, and they're like 0.001% of code that I've written. Everything else is JavaScript, HTML, and CSS.
I disagree with that.
Everything else I've written.
No, I disagree with that.
You can't disagree with, okay. What is this?
I don't agree.
Okay. That also checks out.
I don't know. I don't know.
So if I could write in any other language, I don't know, I'd make one up that looks exactly like JavaScript.
Oof.
okay.
Oof.
Then we have 2 JavaScripts. Now what are we going to do?
The cool thing
Now
is
there's
that
2 of
mine.
them?
The cool thing about mine is that it also runs in the browser, something that you can't really do with any of the others.
Okay.
See, now he's getting
I like
fired
it.
up. We're getting there. We're getting there. We're getting there. We're getting there. Lisp.
I've never written
Right.
in Lisp. I've
Why
heard
not?
good things from smart people, but that's as far as
That's a mean thing to say about Lisp.
Have you heard of Rust?
Rust.
Yeah.
Yeah, I have heard of Rust.
That's
Have
great.
you heard bad things
I heard
about
you're not supposed to say Rust because the lawyers will come after
Rust,
you.
Rust.
Rust? Rust Foundation, HTMX.
Yeah, yeah, yikes.
Yeah. The stream got DMCA'd, so
Oh.
we might do it again with Rust. I don't like Rust. I can't get strings to concatenate. How do you do that, Warren? How am I asking you how to concatenate
ask me.
strings?
It's
Shut up.
format macro.
Format macro?
Yeah.
What are you, 5? Using a macro to concatenate? It's crazy.
Yeah.
Ownership? What are we, capitalists? Okay, we're good. We're leaving it alone. We're leaving it alone. It's very capitalist.
Who are you voting for?
Oh, dude, stop. Voting. Voting. Who are you voting for? No, I'm kidding. I'm kidding.
You were the
Don't
one who
answer
brought
that
up
question.
voting.
How do you feel?
Bring me to your home turf.
How do you feel about the Ukraine right now? No,
I mean, we can get into that if you
no,
want.
we're not. You're too nice. You're too nice, and I don't know.
Here I am
not that
checking
nice.
my watch. How much longer do I?
Warren,
What?
if Ken were a plant,
Ficus.
ficus, boring. What's up with that?
What?
Reliable?
Yeah.
What are you saying with ficus?
That's just the only plant I could think of.
Yeah.
That checks out.
Yeah.
I don't know, Warren. Okay, Warren, if Ken
What?
were a cheese,
Cheddar.
Okay, we're gonna have to end the episode of Between Two Idiots. Ken, you did a great job.
That's what he
Okay.
thinks.
Warren
you.
and Carson, you lived up to the name. I'm very impressed. Don't step on the mic. Oh my God, don't be an idiot. Okay. Between Two Idiots, everybody. That was fantastic. All right, so we actually have quite a bit of different speaker coming up right now. We have a data scientist. Might be the first one today. I don't know if Nate's considered a data scientist. He was a scientist. He, Flappy Bird and Pong and all that. That was amazing. But today we're actually going to have someone coming up that's doing a data scientist. His name is Jaron, and we're going to hear about geospatial data. Yeah, that's pretty exciting. I don't know where Jaron is. There he is. I don't know you, so I'll just give you a fist bump.
After a lot of inspiration today, we changed the name a little bit. So I'm not a Twitterite like a lot of other people, so just a brief introduction myself. I work as a data scientist. I do a lot of research on the side too. Attended 3 universities. Fun fact about me, every school I've ever worked with or been affiliated with is a different type of bear. So hopefully I can continue that collection as my career goes on. I also teach computer science at the university and serve on the board there. I work with some GIS and biotech startups and do a lot of sports handicapping competitions as well. So kind of touch on data science, kind of touch on development, kind of just try and learn a lot of different things and solve problems, which is ultimately why a lot of us got into computer science. So it's hard to know what to call yourself sometimes. So why am I pretending at a HTMX conference? I think machine learning and artificial intelligence are obviously really big right now. I mean, even attending the networking event last night, a lot of people were talking about it, a lot of people had opinions about it. So I want to touch briefly on that, and then just why it's bigger than it was 10 or 20 years ago, and considerations you can make within your organization or within your personal project to maybe make your AI or machine learning project more robust. And I think geospatial data is a really good way to do that. I think one of the reasons it's a really good way to do that is a lot of it's open source, and there's a lot of it. When you're looking at like financial data, private sector data, sometimes it's really hard to get a hold on things. But geospatial data is generally publicly available, even at the federal level. So we'll kind of touch on that. So before we talk about machine learning, I want to talk about like a classic modeling approach. So this is a research project I worked on in my undergrad. There's a linear regression. We were looking at lobster disease off the coast of Maine. I'm from Maine, so makes sense. In our animal science program, being from Maine, we had lobsters because they're kind of an animal. The important takeaway on this is there's 5 variables. So for an undergraduate student, this is approachable. The variables are up there. We're trying to determine based on a couple of things how likely were they to get the lobster disease. This is something you probably could have done like Excel Fit, R, Python, a lot of software, and like I said, it was accessible for an undergraduate student. And kind of taking a step back, AI was really popular in the 70s and 80s, and then it kind of died down, and some of you are a little bit older, familiar with the term AI winter. One of the reasons it died down is there just weren't a lot of practical uses. I have some of the reasons up here: barrier to entry, difficult to explain results to peers. I have a map of the world with red horses, so I'm going to touch on that here in a bit. So really, the paradigm for AI as I see it has a lot to do with big data. And in a previous example, we touched on something with 5 variables. So this is what the equation would look like. A little math heavy, but like I said, 5 is reasonable. So the big data lifeline. So why did machine learning and artificial intelligence become more popular? So if I was doing this lobster project in 2024, I would have access to a lot more data. I'd have access to like sensors and lobster traps. I might have a digital twin of the ocean floor, which is like a 3D projected model. GPS data from boats. I might have daily catch totals. Data from application users, IoT devices on buoys, so on and so forth. And kind of going back to this idea of variables, we had 5 before. This might be 100, this might be 500, this might be 1,000. Is that really within the scope of something an analyst can do anymore? And is it within the scope of something an analyst can do efficiently? Kind of not really. So no free lunch is a concept that's thrown around in data science a lot. It's the idea like there's no solution that's just always right. There are trade-offs to using machine learning and not using machine learning. It's using large N, so a lot of variables. Machine learning, it's a lot easier to deploy models. Is generally if you're doing a traditional model mathematically, it has to exist in your code base as opposed to a model that you deploy. So the CI/CD is a little easier to handle. Shared responsibility model. So like if you think about deploying a machine learning application, you have a lot of different roles, and those roles can have other uses in IT organization. You don't just have a team of research analysts anymore. And you're managing code and not people and projects. One of the big problems with machine learning models is lack of precision. So that picture I had of the map and the lobsters earlier, the PowerPoint AI, so I assume some Microsoft product, tried to put a caption on it and told me, map of the world with red horses. Because that's what artificial intelligence thought that picture. Earlier it was map of the world with red horses. Obviously it's the coast of Maine lobsters, so close, not all the way there. And that's kind of the precision issue. So it's difficult and the answer needs to be exact. So anyone who's used ChatGPT, it's hard to reproduce results. The answer is not always exact. It can struggle with edge cases, issues solving new problems. So you need to have training data generally, unless you're doing unsupervised learning, but that's a different conversation. And ethical and legal issues and a lot of other things. But we're seeing it everywhere. And it kind of comes down to the idea of big data, of all these trade-offs here on the right side, we've considered to be worthwhile just the pure reduction of cost of dealing with that much data. Like, we're willing to take all these trade-offs as opposed to hiring like 50 analysts, basically within an organization. Because it's just too much data for people to deal with. The machine is, really good dealing with a lot of it. And those variables, a lot of them in that previous slide, would be dependent on each other. So in that lobster project specifically, the population density is highly correlated with temperature. Because if there was, a certain ocean temperature, there'd be a lot of lobsters there because that's where they wanted to go to lay their eggs, because they like a certain temperature in degrees Celsius. I would have to do dependency tests. I would have to do statistical tests to figure that out. Machine learning, it's pretty good at figuring that piece out. It's pretty good at figuring out what's dependent on other things and so on and so forth. And like I said, not perfect, but what I'm getting at, it saves a lot of time and money in the price of being exact. And this is GPT-3 and 4. Really, the big takeaway I want you guys to take from this is just the amount of variables. What I'm getting at here is the models are changing, but if you were to look at like academic papers for AI, like convolutional neural networks or things like that, there's a decent amount of them coming out, but the technology is not moving as fast as like the product in front of you. The reason the product in front of you is moving so fast is really more of a testament to DevOps. Like, training on that many variables and that many machines is really, really, really difficult. And I can't even imagine how many analysts it would take to do that. But obviously, a machine is capable of doing it and serving it to each person in this room. But, like I said, problems with exactness. So, like, if I were in a hospital and I was having anesthesia, like, administered to me, I wouldn't want, like, an ML model to do it, or I could potentially die. Like, I want an anesthesiologist to do it. So really kind of what I'm getting at is, big data led to like a rise in machine learning. And so as an organization, if you have really small or dirty data sets, it's going to be difficult for you to kind of accept some of these workflows, accept some of this technology. What I've done in a lot of the startups, organizations, and stuff that I've worked with is I've used geospatial data to increase their organizational data set. So let's say I had 5 variables previously in the lobster model. I might be able to use geospatial data and create more of that. So what I have an example here is, for those of you who are familiar with Kaggle, I grabbed a data set in Kaggle, and this is just some housing data for the United States. And this is Big Sky Devs Con Incorporated. We have a couple of variables. I go to the next slide here. You see a lot of these are missing lat long. Generally, the first thing you do is geocode and fill in the lat long. We'll get to geocoding a little bit more later. But why I'm putting this code up here is I want to prove that it's not that complicated. I'm a data scientist. You guys are developers. I hope that any code I write, you guys can figure out. So this is what it looks like on a map. It's actually pretty cool. I chose to dial in one state. So this is the state of Washington. This is property price in thousands of dollars on a map. And so we want to develop a model to use this. The problem when we go to look at a model is we look at our correlated features. We don't have a lot of data, and we have a lot of really dirty data. So we want to make a machine learning model. We only have 5 or 6 features. That's probably going to be a problem. That's probably something that would be better just hard code mathematically. But, your boss says, I really want ML or AI. So, how do you get more data? Yeah. So and for all you bosses out there, talk to your data engineer before you tell your developers to roll models out. So one of the first things you can do is just clean up what you have. So this is me generally cleaning up what I have. I saw that the land space, some of it is in acreages and some of it in square foot. Obviously normalize that. And then we take the property type. So we look at, it's the string field. We do something called one-hot encoding. We look at what type of home it is. You can see condos and manufactured homes have a negative correlation with price. That makes sense. Single-family and multifamily homes, so kind of regular houses, are more correlated with price. Most people would rather buy a home than a condo. That makes sense. So I still don't have that much data. That's the problem. Like, I cleaned up what I have. This is the best I could do with what I have. Until I start to use the GIS data. So this is a physical boundary. This is a shapefile for the ocean, and this is all my previous data. So I take each house and look at how far is that house from the ocean. That makes a lot of sense to me. In Seattle, I would think, or generally in a lot of places, Washington, Tacoma, places like that, there would be a correlation of how close you're to the ocean versus how much is your house worth. That seems like something really useful for a model to have. So this is a code sample I use. There's a function here that saves on some of the heavy search operations by doing a lighter search operation first. And we see that distance to coastline is a somewhat correlated feature. So our data set's getting better and better and better. Another thing I like to use a lot is we have the census, the people who knock on your door every day, or every 10 years, not every day. All that data is publicly available for you guys to use in like any application. So these are the census tracts from Missoula. Tracts are actually pretty cool. So they're population limited, and they try and do distinct areas. So anyone who's visited Missoula, you see tract 5 here, roughly the university. Most of those houses are, roughly similar to each other. And then you have the different neighborhoods here. So you can take your data and you can join it off on the tract, and you can get that, like census data, extract that census data. So this is median year housing unit built in Missoula. So this is something we could look at. We could say, is there correlation between, in these areas, when builds are happening in price? That's something you often see. And pretty much any town, Missoula included, you look at the river, it's usually the older houses, and then off the river, you usually see newer stuff. And it makes sense. Like 100 years ago, people probably need to live closer to water, but different now. And then maybe houses built before 1939. So they also have like 10-year increments. So you can look at each 10-year increment, what percentage of houses in that area are being built. And, Missoula, again, using it as an example because it's where I live, and quite a few people here probably live. Same thing near the river, you see a lot of old houses. There's a tract, there are almost 45% of the houses built before 1939. That's like kind of crazy when you think about it. But we go back to Washington. So they also have areas of growth, which is a statistic of how much is being built or not built in an area. Sometimes that's correlated with price, sometimes it's not. It kind of depends on the area. And that's something you can statistically figure out. The point is you can extract and get that data. So the way most people get it is a spatial join. So it follows kind of general, join paradigms, right, left, outer, inner, but it's spatial. So you can say, does one object contain the other one? Does it intersect? Does it touch, cross, whatever? So I take all of those lat long points and I spatially join it on those tracks to extract the data from within them. And this is what a spatial join looks like. It's really simple. The only thing I'll touch on here, and I actually talked to a couple of people last night, make sure the coordinate systems match or your stuff's just not going to work. It's weird. It's a GIS thing. If you do that, like most other things will be fine. So there's a little blip there where they're checking if they're the same. And if not, it sets them equal to each other. And it's kind of the idea of keys. So in this spatial join, I'm using lat long as a key. Different geographic keys can be like a state ID, zip code, county, tract ID, or address information via geocode. And then you take these data sets and join it off on your own data. So this is an improvement. I took a bunch of the census data and joined it off, and you can see I have a bunch of features that are significantly more correlated. My model is probably going to do quite a bit better now. You see I have a new second best feature here. It's median household income adjusted to the last 12 months. That makes sense. That is a really good feature. Probably looking at housing prices in an area, I want to know how much people make. So that feature's on there now. You can see the 10-year increments. You can see a lot of different stuff on there. You can see area of water within that tract. Is that correlated? Is that not correlated? I'm doing the whole state of Washington, so it's a little dirty, but I didn't want to do independent data sets by zip. But if you were to do it as zip, you might see like in Tacoma, living on water in your tract, your house might be a lot more expensive because there's not that much water there. But I'm from Maine. There's water everywhere. There might not be correlation. So it can be dependent on the area. So you also have raster data. This is a more advanced topic. I'm going to touch on it because I think it's actually going to be pretty important in the next 5 or 10 years. The big takeaway for this is there's a lot of publicly available raster data. It's not that hard to get your hands on. If you have a data scientist who's familiar with the convolutional neural network, just like what Tesla uses for a lot of their driving stuff. And it's what a lot of people use for image detection processes. A lot of stuff just kind of works out of the box with raster data. So you can take, this organizational knowledge. If you have somebody that does image detection or analysis, they should just be able to handle raster data. It's really not that different. I mean, you had different zoom levels, but even if you were to pick like one determinate zoom level, it's probably just going to work. And you can take that raster data, it's an image. Most people know what an image looks like. We're free to break it down by pixels and colors and stuff like that, and train on it, and you could throw that into your model as well. And this is, roughly what it's doing. So this is a picture of a dog. This is kind of how ConvNet works. I like it as an example. What a ConvNet does is it really tries to focus on like the features that make something something. So like a dog, it's going to try and look for the ears. It might look for certain color patterns. It might look for the teeth. If you're trained on dogs and cats, it's going to look for the things that try and tell a dog and a cat apart. When you're looking at that raster data, it's probably going to look at things like water, trees, roads. And it works pretty well because those things are actually pretty different than each other. Cats and dogs, funny enough, that data set, especially if you get like something that's not incredibly cleaned off Kaggle, can be tricky. Like they both have ears, they both have snouts, whatever. A river and a road generally look quite different from each other. So it works pretty well. ConvNets work really well with raster data. And this is a research paper. This is kind of what a ConvNet looks like when it cleans up raster data. And you can see it's just kind of in that last interpolation, the red and blue one, it's focusing on a feature and what makes that area an area determined by like what they want to look for. So I kind of took an out-of-the-box ConvNet and applied it to our model. And so I took these little pictures from an area. I took satellite imagery. I tried to do it all at 5 p.m. on the different houses, a picture of each house. And so within that house, I looked at, there are little vehicles, and you can see in the picture this ConvNet can determine vehicles and roads. I looked at roads. I looked at road square footage, and what I determined to be forest and forest square footage. And you can see that, if you have forest near your house in Washington, it's probably going to be more expensive. If you have a lot of roads and cars near your house at 5 p.m., it's probably going to be cheaper. That makes sense. People don't want to live near traffic. Generally, when people have money, they buy land, especially out west. So very generally, takeaways. I didn't want to put a bunch of precision recall graphs up here. So these are obviously text. The model performed way better with more data. That's just very generally true to ML. I don't feel like I have to get too into that. I used a couple of different out-of-the-box models, and somebody says a model performed well. Like they're kind of, at the hands of whatever model they're using. So I just used a couple of out-of-the-box. Time to process data and analyze it was significantly reduced. Just kind of throwing it into a ML framework as opposed to doing everything by hand. If I were to go through each one of those 100 things and try and make a mathematical equation and put that mathematical equation in the code base, it would take me a long, long time. I probably would have had to hire more people. And as model as a service becomes a norm, and this is kind of a different topic, data is going to get more and more important. A lot of people now, and especially people who work on front-end applications, you are calling out to a model. So you might be calling out to ChatGPT to do something generative. You might be, sending it a PDF or text data and having it do something. And I think model as a service has become more and more like a thing as we get in the next 5 or 10 years. Just the pure cost to train a model and to have your own data center and do stuff like that's really, really tricky. The one thing you do have control over is your data, though. So really organizationally thinking about what data you have, what data can you get, things like that. Because data sets are always going to be hard to get. People are going to privatize them. If they become worthwhile, people are going to try and sell them, so on and so forth. That is the thing you have control over. I think models will become more centralized. So focusing on your data is really important. These are some additional tools I like. I'll just run through them really quick. OSM's awesome. This map key here on the right, all those features, and there's probably way more. I think the legend went down probably twice as long as this. Every one of these features you could join off in the data set. So for our housing model, we could say is the house near a cable car? Is the house near a track? Is the house near a motorway? How many motorways is it near? How many bike paths is it near? And mileage, things like that. A lot of those things can affect something like housing price or any model. You could be looking at a lot of things. Natural earth data, same thing. Pretty much any GIS analytics project I start by getting a natural earth data repository in there. So physical features like water, states, tracks, zip codes, things like that. It's free, it's great. USGS Earth Explorer, kind of same concept. You can go in an area and you can get raster data. You can even get some cloud cover stuff, so on and so forth. And then hydro sheds, and this is the idea of rivers and streams and having a three-dimensional model that looks at how deep things are and stuff like that. And this is actually kind of important, is if you were to think about an area that's wet and you were to do a housing model and you were to say, if this house is near water, is it worth more money? Maybe your model says it's not worth more money. And you're like, I swear to God, everyone who lives like down near a river, their house is worth more money. This doesn't make sense to me. You pull up a hydro shed, you realize that the reason the model is doing that is a lot of people live near swamps. And swamp is technically water, but their house isn't worth more money. So you change your model and you say, do you live near water where depth is greater than 20 or 30 feet? And then it works. So thinking about, the z-axis and just having more available data, hydro sheds are really useful. And this is another picture of, I just like maps, so I threw a bunch of them in here. In QGIS, I want to touch on this. This is a great open source piece of software. It's cool because a lot of non-developers can use it because it's GUI. It's even cooler because the API, like a lot of the stuff that the analyst would do in the GUI, a lot of times you can just copy the code out and put it into your code. So like the API is pretty exposed and most of it's kind of out there. So if you have an analyst and you're like, oh, I made this really cool thing, but like the person doesn't write a lick of code, like, oh, cool, what did you do? And they'll show you like, I ran this tool, I ran this tool, I ran this tool. And you're like, okay, API, copy, paste, copy, paste, copy, paste. And there you go. So having something with a GUI with like an exposed API, and a lot of the GIS APIs are in Python. So like the CI/CD perspective of just like getting the code in there is not too bad. So I also have the idea of free features, and this is one of the things that I think is the coolest about GIS data. So we had that initial like data housing set. So imagine you had a mobile application where like users are going in there and looking at housing data or web application. You only have so much data to display. We saw we had 5 fields. We didn't have that many land features, so on and so forth. So as we add all these things to the model, they become part of our backend. They become part of our code base. Generally there stores a layer or something like that. It's incredibly easy to load them on the front end. I call them free features because a lot of times, like, your boss gets on and they just see them on the front end because they're added to the back end and the code to load them is incredibly easy. This is what it looks like to load a layer. So if I joined all of that stuff off on the layer and we had 5 features before, we wake up tomorrow there's 15, same line of code, your map just has more data. It's a new feature, maybe you can do a filter or something with that. So this is kind of what it looks like. This is a project I worked on. We analyzed world traffic surface in like a time series. We had that as part of the database. And now our map, we have the traffic data. I took this area. I think this is the traffic data around noon. You can see the busy or not busy areas. We just kind of threw it on because we had it. And the point is we had it because we joined it during the analysis process. And this is it scoped out. I like this because you can see the accidents. These were the accidents in this area around noon. So additional considerations. I'll kind of go through this a little bit quicker. I think the raster data is really important. A lot of first world countries have line of sight laws for drones. They are more laid back than ours. We have some pretty tight line of sight laws. A lot of the line of sight laws are being pushed from like a House and Congress perspective to be dialed back on. One of the reasons they're being pushed to dial back on, I think, is industrial reasons. I think Amazon probably wants the ability to use more drones, things like that. What I'm getting at is I think there's going to be a lot more drones in the next 5 or 10 years. When I'm at Ezra or any GIS conference, it's kind of a big topic of discussion right now. I think people who are working on raster data or working in data in this scale, I think we'll kind of have a one-up because I think that's just going to be a big part of the tech economy in the next 10 years. Drones are really useful and really good at what they do. The reason you don't see them anywhere is we have strict laws that they're currently trying to get rid of. Most of this code can be appended to existing data and pipelines. Like I said, I included the code to prove how easy it is. Like most of it's 1 or 2 lines of code, just join it off in your data and store it. And improvements in technology. So like I briefly want to touch on this. There's a lot of organizations that have tried to use geospatial data before, and they had problems. So like the previous geocode API I used is the census one. It's finicky. If you don't put the address in exactly, it's not going to give you what you want. This is the Google. It's a lot better than it was 5 years ago. I just put in the Commons Bozeman and it knew what I was asking for. So let's say you're a company with really dirty address data and like GIS just didn't work for you 5 years ago. Look at it again. Look at the APIs. They're probably a lot better than they were before. And there's a good chance you can get onboarded when previously you would have had problems. And so like this is some general advice. ultimately it's about the data. Don't try and reinvent the wheel and think about like one-way, two-way doors. I talked to a bunch of people last night about GS applications, and a lot of people were like, oh yeah, I made this front application, like it worked, the map was awesome, and I got too many points. And that's something I hear from like everybody. Because working at GS data is different. Like you have to deal with spatial indexes, you have to deal with like how you're storing the data, whether you're doing a layer, whether you're like rendering it on the front end, a lot of different, processing on the server, not processing on the server. It's really good to sit down and think about all those things before you get started. Because a lot of times people get in these projects where, they're collecting points, they end up with 800 points, they have too much existing code, it's hard to go back and fix the problem. Like most GS problems like are big data. You will have a lot of geographic data, so think about like the choices you're making, what they're gonna look like long term. A lot of times when I'm load testing a GS application, what I'll do is like if I have 10,000 features, I'll just multiply it until I get 2 million features. Maybe do like a random number generator to make the lats a little different than each other and see how I'm doing in loads. Because like if you just try and put like Zillow, if you just try and put that many houses in a Google map, you can probably render that on the front end and you're probably not gonna have that many problems. If you want to put 50,000 of those, like if you're collecting like frogs in an area for like a government contract, it's probably going to crash your front-end browser if you try and do something like that. So if you want to keep in touch, I use LinkedIn once in a while. I use Strava a lot more. I'm not on Twitter like a lot of people here. Those are what I use and how to keep in touch.
That was awesome. I like maps too. So does Bilbo Baggins. That was like one of the defining features of him, why he went on the great quest, is because of a map. That's all it took. So yeah, all you have to do is bamboozle somebody. It's nerd sniping back then. Crazy, right? Okay, so we got some more people, a few more talks left. We're gonna bring up Marcus, and he's a lead engineer over at Good Ventures, or Very Good Ventures, not even good, not even great, but very good. And he's gonna talk to us about Flutter. Now, I've heard a lot of things on Twitter about Flutter, so I hope you can clarify, because I thought it died, but then it was back, and where are we at? Let's go. Appreciate that.
Hello, everyone. Well, what's that? Good. Is it not morning? It feels morning. Yeah, as I get it set up here, can we just agree the HTMX con joke? Like, we've played that out, right? Like, I don't need to, HTMX, that's it, I'm done. That's all you're gonna hear from this one. Yeah, I'm not CEO of Flutter. I wish I was. Let me make sure this audio is all set up here. Awesome, oops. Alrighty. So, as I said, I'm Marcus, engineering lead at Very Good Ventures. We're a fully globally remote consultancy. And so I work in Billings, actually, but I am an alumni of Montana State. Go Cats! But yeah, live in Billings with my wife and 2 boys there. That's a picture of us at Cloud Next recently, some of the Very Good Ventures team. Since we're all remote, it's weird when we get to like meet each other in person. Normally, they're just computer screens. But anyway, today, I'm going to talk about...
I mean, what's the deal with
Flutter?
What's the deal with Flutter, right? Quick show of hands, who here has heard of Flutter? Okay, everyone, that's awesome. Anyone download Flutter, play with it? Has anyone, okay, most of you, or some of you, half of you maybe, has anyone shipped an app to production with Flutter? I see a handful of people. You guys, this may be kind of boring, but for the rest of us, we're gonna go through and learn all about what is Flutter, what's the deal. So, I'm gonna start out easy mode. I pulled this straight from the Flutter website. What is the deal with Flutter? It's an open source framework by Google for building beautiful, natively compiled, multi-platform applications from a single code base. Okay, so we're building apps here. This is all front end. There's no server rendering component to this. It's only the pretty part of building applications. It's 100% open source. There's no proprietary bits in the entire stack. And you get natively compiled applications, one code base to a bunch of different platforms. Which platforms? These platforms. iOS, Android, web, Windows, Mac OS, Linux. There's even some experiments like with embedded stuff. You get all this from a single code base, which I think on first face pretty cool, but we've probably heard this before if you've heard of Ionic and Cordova and Xamarin and React Native and Kotlin multi-platform, and even Java's tagline, right, was write once, run anywhere. What makes Flutter think that it can deliver on this? This is probably what you've heard about Flutter, but why can Flutter deliver on it when maybe some of those other ones didn't deliver on it as well as we'd like? And I think to really understand that, you're gonna have to bear with me and dive a little bit into how Flutter works, just a little bit, to understand why it's cool. So, we're gonna go into the iceberg. Starts out with your code on the top, right? That's the actual bit that you're creating your app. You interact mostly with the Flutter framework. So we call them widgets. There's like the base UI component, things like text and images and buttons and switches. All of that is part of this Flutter framework. Also all the gesture detection, scroll views, rows and columns to align stuff, all of that is built into Flutter. It's like its own piece, part of the framework. But all that code gets compiled alongside a Flutter engine. It's actually a whole full-blown rendering engine. There's actually two of them now, an old one you might have heard called Skia, and then now Impeller is the new one. And this is all written in C++, but it literally is its own rendering engine. And so it actually works kind of like a game engine. If you've ever used Unity or Unreal, where you're painting every single pixel on the screen with that rendering engine, right? We're not mapping to native components, like that's how React Native works, right? You're bridging over to actual native iOS and Android components. Here we're not doing that. We're actually creating them ourselves. There's also Dart, which we'll talk about in a second. That's the programming language. That's also compiled the runtime alongside it. So it's all kind of bundled together with your code. But even that sits upon the actual hardware itself. So everything gets compiled to the chip that your device is actually using. So if it's ARM, if it's x86, if it's web, you can either do JavaScript or now WebAssembly, and it actually runs commands against your GPU. So if you're using Metal on Apple, or you can set up OpenGL on, for other platforms, it actually is native code sending those commands directly to the GPU. So that's why you have native performance. It's like actual machine code for your chip, and that's what your app is. It's not a web wrapper or something like that. But then since you also control every pixel, you can do anything, right? You can even write custom shaders that control exactly how your app looks if you want. Of course, you don't have to do that, but you have complete control. I did want to talk a little bit about Dart. Sorry, this is going to be the text-heavy slide here, but just some things about Dart. It is an object-oriented language. It's a strongly typed language, but it has lots of good type inference, and so you don't have to specify types everywhere. It has sound null safety, which is really cool. It means at compile time, your code is null safe, and so there's a lot of optimizations that you can make in the binary because you don't have to do null checks in that code. Also, you basically can't have a null pointer exception in Dart, which is super cool. It is a garbage collected language. I know for some people that's great, and some people hate that. Your mileage may vary on that, but I've never had an issue with it in Flutter. Has a C-leg syntax, which we'll see in a second. I like to joke it's kind of like Java and JavaScript had a baby, is how it feels to code. There's also higher order function support. So like list mapping, lists, filters, all that you'd be used to in JavaScript is in there. And a lot of syntactic sugar, like a lot of the things that we like to use, ternary operators and spread operators, null-aware operators, kind of all that stuff that in a modern language you'd kind of expect. Dart has all that. The other cool thing about Dart is there's a ton of compilers. So this is actually why Flutter chose Dart, is because there's a lot of things that you can compile it to. So like I said, x86 or ARM, WebAssembly. There's actually 2 JavaScript compiler transpilers, one for production and then one for debug, so that you get like better symbols on debug mode. And the whole point, that's basically why Flutter chose Dart. One of the reasons is that you can send to all the different platforms, right? If you're a multi-platform framework, that's important. It also can compile ahead of time for those efficient binaries that we were talking about, and just in time. So we're gonna see in a second the demo with a really cool feature called hot reload, and it's all powered because you can actually just recompile bits of your code just in time as you need it. So for debugging, it's super important, but then you can do an actual build ahead of time and get the native performance. So I really like Dart. It's kind of weird. Like, not a lot of people are coding in Dart outside of Flutter, but I think if you've used any language in the last 10 years, Dart will be super easy to pick up. So let's see some Flutter code. I'm going to go to a little demo here. So this is the counter app. This is if you build a new Flutter app, like you install the CLI and everything, and you get Flutter new, you'll get this app. It's real simple. It just counts how many times you click this button. But I'm going to use it to show you what the code is here. It's an object-oriented language, so we have a class like you'd expect. You'll see it's extending stateless widget. So I said everything's widget. It's the base UI component. So like this whole app is actually a widget. And then you can see it's composed of other widgets. So it has a my homepage, which is itself. This is a stateful widget, but it's still just a type of widget. And then if we find every widget has a build method, which returns just a widget. I said widget about 30 times there, but that's basically how this framework works. Inside of it, you can see we have an app bar. We have a column that aligns things vertically here. And you can see we have like our 2 text widgets. I mentioned it's 100% open source, so I can just command click in here, see how text is defined. So this is like in the actual Flutter framework itself. You can see it's also just a stateless widget. But it's cool. So if you're ever troubleshooting something in the framework that like isn't working the way you'd expect, you can just go and see how it's implemented super easy in your IDE. It literally is open source all the way down to like the engine's all open source. You can see what GPU calls get made. It's 100% open source. And then, so I was talking about hot reload. I want to show you that. So for example, I'm going to scroll back up here. You see we have our theme here is this blue color. Let's say I decide I want to make it red instead. All I have to do is save, and it's instantly, like within milliseconds, updated. I'll say I've worked on Flutter apps that are millions of lines of code, and it's still that fast because it's smart and knows how to rebuild only the pieces it needs to like make your updates make sense, like to be in sync. And so if you've ever done like native development with iOS or Android, you have to recompile everything from scratch if you want to actually use your app. Because I should say, this is a real running production app. This isn't like an emulation or something. This is the code that will ship when you release this app, and it can just change just like that. But it's more than colors. You can literally change kind of anything. You can change this text. You push this many times, maybe a bunch of exclamation points, and it updates. You can even change, I don't know, we could be here all day, right? You can totally rearrange your app, add widgets, remove them. You also notice it's a stateful hot reload because this 7 is still here, and even if I change it up, it still keeps that variable. So everything stays in memory, and it only changes like the bit that you changed. So when you're actually developing, that's really how you develop in Flutter. You're kind of going back and forth, make a change, see how it affected, and it's like this feedback loop that makes it really efficient to develop in. Just a quick note on like how the state management, the basic stuff works. It's a reactive framework, just like React or Vue, or kind of if you're familiar with any of those. You'll see for my homepage actually has a state object tied to it, so we create that state, and in there we just have a property on the class, counter, started at 0, and then we have this increment counter function, which is called on this button press here. So hopefully that looks super familiar to all of you. And basically this function just increments the counter and then wraps it in the set state function, which basically tells the Flutter engine, hey, whatever happened in this closure, change the state, we need to rebuild. And of course, there's debugger support and things like you'd expect. So if I drop a breakpoint, try to increment this, you get kind of what you'd expect from a modern debugging experience. It's all kind of built into Flutter. So that's Flutter. That's super quick, but that's kind of what it looks like when you're developing Flutter. So now, often, maybe you're thinking, this seems cool. Maybe I need to check this out, but I have a lot of questions. I wanted to preempt a bunch of common questions. So can it? Let's see. Well, I rearranged the slide, so that didn't make sense. But are there packages like npm create? There is. It's called pub.dev. We joke Flutter developers spend way too much time at the pub, and that's where there's tons of open source stuff from Google, from the actual Flutter team, but also just everyone else. There's a huge community of open source packages for doing common tasks and kind of other widgets, whatever you need. It's kind of like what you'd expect on other platforms. Can you use native APIs like GPS and stuff? Absolutely. There's kind of a bridging framework that it has between the Dart layer and like native layers. You can write like Swift code or Kotlin or whatever you want and basically pass messages back and forth, which is pretty cool. Like anything you can do in a native app, you can do in Flutter. Sometimes if it's really on device, you just have to write a little extra code. I'll say for stuff like GPS or accelerometer and stuff, there's packages for that. People have already done the work that are really good. So, but if you have something special, absolutely, you can still use it. Can I make it look like a native app? Yes, you can, with an asterisk, right? We're shipping the whole Flutter engine, so we can't use native iOS components, for example. But what there is a library that ships with Flutter called Cupertino to avoid trademark infringement, I believe. And basically, it has widgets that are built in Flutter, but they look like iOS components. And there's also one Material, which is for like Android, and there's lots of other open source ones for any platform that you kind of expect. So you do have to make it look like a native app, but because you're actually like painting every pixel, but you can still do that if you'd like to. Does it bloat my app size? I hope some of you are thinking this, because you're like, hold on, we're shipping a whole rendering engine alongside the app. Why? Like, that's got to add a lot of stuff. And the answer is, yeah, it kind of does, frankly. Like that example app I showed you, if you compile it to an APK, it's about 20 megs, which is more, you know, if you're really sensitive to your app to like bundle size. For example, instant apps, which is something on, I think Android and iOS both have a version of it. You can't really do that with Flutter because they have to be under 10 megs, and the actual base engine is more than that. So just something to keep in mind. In practice, I've never seen it be an issue for any of the clients that we've worked with. Generally, most of the app size is your app. It's not actually the engine, especially as it scales to like a real-world app. So something to keep in mind, though. What IDE should I use? I was using VS Code in that demo, which totally works. It's probably the most common one people use. But you can use Android Studio, is also fully supported and common. But there is a language like server protocol or protocol server or whatever. So you can connect it to anything. I've seen NeoVim and Zed and all sorts of stuff. So you can use it with your favorite IDE if you would like. Can you do unit and integration testing? There's actually a framework built into Flutter for doing this testing. So it's cool, everyone uses the same one. It's different than like the web world where there's a bunch of different ways to test your app. And because everyone uses the same one, like the examples that you find online, there's just lots of good content if you're confused or stuck on something. We actually at Very Good Ventures enforce 100% code coverage on every project that we do. So if you ever go to our blogs, we'll never shut up about unit testing. It's well supported. And finally, do I have to rewrite my app completely? You don't have to. There is a system called Add to App. So imagine if you have an Android and an iOS app that are native, and you have one screen that you want to add to both, then you can actually create that one screen in Flutter and then stitch it into your native app kind of seamlessly so your users wouldn't know that it's a Flutter app, or a Flutter page, I guess, in that sense. And we've actually used this with different clients to adopt Flutter over time. So instead of just completely starting from scratch, let's just try this out and step in our toes in a little bit and gradually adopt it over time. But I think the biggest question, elephant in the room maybe, why should I trust it? I know there's about 6 of you I saw that as soon as I said it's open source from Google, you're like, I'm out. Like, they're going to kill it by the end of the sentence probably. But so yeah, it's a good question though. I think it's something that if you're thinking about Flutter, you should be thinking about this. For what it's worth, Google uses it a ton. That's like why they built it, is to build their own apps. These are just a few of them that they've built. They've like migrated to Flutter, things like Google Pay, Google Analytics, Classroom, Google Earth, the YouTube Creator app. Also, that little triangle one is the Google Ads app. So you can actually like buy Google Ads with a Flutter app, which is probably in Google's interest to keep around. So it gives me confidence that it would be expensive for Google to kill Flutter because they'd have to rewrite all these apps and more. So that's something. And then also, for what it's worth, a huge community has started to adopt Flutter, lots of big brands. I'm not gonna read them all. One I did specifically want to call out is Toyota, because they're actually rewriting their whole infotainment system in Flutter. So like maps and music and stuff that goes in the screens in their cars. Hopefully next year, we'll start seeing cars shipping with that version. I know about that because I got to work on that project, actually. It's super cool. It's like a different use case for Flutter than just the standard iOS, Android, but they're all in on that. It's like 100 developers working on it. It's a huge project. But, oh, sorry, I did just want to go. It's not just a wall of logos. I wanted to show you some apps that have been built in Flutter just to build confidence, I guess. I don't know. IBM was one of, or sorry, not IBM, BMW, lots of acronyms, was one of the first companies to go in with Flutter. That's like their car companion app. Betterment is on the far left. They're like a bank that they rewrote their app in Flutter. They're actually one of them that has incrementally adopted it. So they started with just a few pages, and now it's 100% just Betterment. And the middle one, that's the musical Hamilton. They were one of the first people to build an app with Flutter. It's like a companion app to the show. So there's lots of games and other content, and you can, I think, enter lottery system for tickets through it. That one's cool because, yeah, it was 2017, I believe, by Very Good Ventures, actually, long before I was there. But it was the first like real production app. They're still using Flutter, still going well for them. So just to give you an idea, you can make real stuff with Flutter. But I did want to talk about app development in general. Like, why does this all matter? Are there app developers here? Like people that work on Android, iOS? A few of you. This should look super familiar to the traditional way, right? Someone creates a great design, your designers build something beautiful, and then they hand it to these different teams and say, hey, teams, make it happen on Android and iOS and web, right? And then these different teams who have completely different technology stacks, they can't really work between each other, have to build the thing and make it look as close as they can to the design with completely different tools on completely different schedules. So that means you need a lot of like PMs to organize everything and make sure you're tracking toward a release that's consistent. And also, by the way, there's a backend team that's also trying to work with all these companies to get everything working on all these different platforms consistently. And it's just a lot of overhead. You need a bunch of different teams, a bunch of like management costs just to keep everything going because there's a lot of people involved in a lot of different kind of priorities. In the Flutter world, it's a lot different. You just have one Flutter team that talks to the designers. And you'll notice I put 2 arrows there because since it's such a smaller, more condensed, efficient team, often, and stuff like hot reload honestly speeds up development a ton, you can kind of work back and forth with your designers, right? There's like before, if the iOS team said, hey, we'd like to update the design in this way, it'd have to go back to the designers and then they'd have to agree with the Android and the web people or whatever platforms you're doing. Here, it's just one team, so you can be really efficient and like iterate your designs a lot faster. Same with the cloud team. You're working just one team with another team, so you can iterate a lot quicker between them. And really, I think this is the part you should care about the most of all of this, is that with Flutter, it honestly reminds me a lot of what Ryan was talking about earlier, that we don't have to think about which technology we're using, right? The technology doesn't matter so much. It kind of pulls away. It's just one app team building one app that just happens to deploy to all these different places. It means that you can just focus on building value, right? Focus on the product and actually delivering what you want to, and you don't have to think about what the technology itself is, right? Flutter really enables you to just build stuff, which I think is probably the goal for all of us in this room. So, thank you. And I will say, if you want to learn more, come find me. Flutter.dev is all about Flutter, and if you want to know about Very Good Ventures, of course, you can always find that on the web too. But yeah, thanks.
That's great. I have two pieces of news that we have to talk about. Number one, Marcus, I think that Twitter may have spread misinformation.
Oh?
Yeah.
I've never heard of that.
I honestly thought Flutter was dead. It didn't look dead.
Yeah. Yeah.
Dude, you really did work on the Toyota displays?
Oh, yeah.
I don't know how I feel about those car displays. They're a little distracting. You know, I like to touch knobs. You know, now I'm looking at screens, getting in wrecks.
Yeah. Wait for the new ones. Wait for the new one.
Okay,
You'll have to tell me that.
I'm waiting. It is a skill issue. All right, the second announcement, which is probably the more important one, is that it's now snack time. I hear that developers, at least based on Google's, you have to be so many feet away from a micro kitchen because you can't go throughout the day without eating something. So there you go. There's a whole bunch of stuff in the back. And so speaking of Google and Flutter, so go, get it, enjoy. Go, run. All right. All right. Hey, Vladimir, you having a good day? That's good. Hey, I remember you from last night. I ran into 5 people now total that worked at Computers Unlimited. Who here has worked at Computers Unlimited? Poor souls. Oh, you worked there too? Yes. The number's going up. It's like stocks in here. All right. Well, I know there's a lot of people. I was shocked about that. That was actually my first job ever was Computers Unlimited. So, well, not my first job ever. I worked at Texas Roadhouse and Subway and all that stuff. That's not fun. I don't recommend being a sandwich artist. All right, so we have a very delightful guest. The first time I ever met said guest, he was shirtless in a hot tub, which makes sense. I mean, it'd be weird if he had a shirt on, honestly. And he tried to pull me into the hot tub at React Miami. I was scared for my life, started running. Anyway, so he's fantastic. He builds UIs, he teaches, he has his own podcast, his own YouTube channel. He's very, very tall, and Ken Wheeler tried to wrestle him, and he lost. This man can wrestle Ken Wheeler, so here comes Sam, by the way. Yeah, Sam, let's go.
Do I get to hug you?
Oh, you can hug me.
Okay, I'd love to.
Oh, gosh, you're so tall. It's like...
All right. USB-C. There we go. React Miami was a lot of fun. It's very much like a vibes conf. If you've never been to React Miami before, I highly recommend it. Cool. That's the end of my show. Let's go to the beginning. That seems wrong. How do I make this full screen? Like that? All right. So my name's Sam, and my talk is called High Floor, High Ceiling. And I'm really glad that I went after Ryan because Ryan was focused on kind of the React side of the argument, how we're trying to solve basically this problem that we all face, whether we come at the problem from the server first or the client first, that we're really building 2 apps, it feels like, and a lot of the abstractions, HTMX and other abstractions that are crossing that gap, try to make it feel more and more like we have one app. And so Ryan's talk was a great look at kind of the latest developments in the React community, how they're tackling that. But I want to kind of take a little step back and just take a higher look and just talk about some concepts that apply to kind of all communities, both back-end and front-end. So my talk is called High Floor, High Ceiling. So what do I mean by this? Well, when I started programming, I was actually using PHP. Symfony was my first web framework. And I was working at a financial software company, and I was making some interactive charts. I kind of got interested in JavaScript pretty quick. I was using D3 back then. But I was rendering a pie chart with some PHP. And you could do it. I was using like HighCharts, I think, a library. And you can render SVG from PHP. But there's one problem, and that is that I wanted to make it interactive. I wanted to let my coworkers click on different slices of the pie chart, filter down the data, and kind of have it update and animate. And, well, PHP doesn't really have anything to solve this problem, right? This is an interaction. It involves event listeners. You have to write JavaScript to achieve this, to pull this off. So this was like one of the first times that I hit a ceiling. I was new to programming. I was using PHP. Symfony is a framework. And it's like a batteries included framework. Symfony has pieces and modules for all sorts of application concerns. And so that's the green box on the bottom. That's like all of the features that you would want in your server-side capabilities in a web app that you're building. And then the blue box on top is the UI. So that's like, think about as you go up, you're building a richer and richer UI. So things like interactions and animations and things like that. So I hit a ceiling because I was building a web app using a tool, using Symfony, and I wanted to build a particular UI interaction, but I couldn't using just that tool. So that was kind of the ceiling of that tool. So kind of generalizing this, I think of backend first, server-side first frameworks like Laravel and Rails, Django, and Symfony as high floor, low ceiling frameworks, right? They start off with a lot of capabilities on the server side, so you can hit the ground running. When you write Rails new and you build a new Rails app, you're basically starting off on the 10th floor because you're going to have a way in the docs that's going to tell you how to do authentication and how to send emails and to connect to the database and model your data. That's the high floor. But the ceiling traditionally has been more limited. So what did I do after that? Well, this is kind of when I started, falling for the JS wave, and this was like about 10 years ago. And at that job, I used Backbone. So Backbone at the time was, it embraced everything I wanted to do in the browser. It gave me primitives like, I guess it wasn't called a component. It was like a Backbone view. And the Backbone view lets you make something that looks a lot like a React component and wrap the DOM APIs that you wanted, things like adding a click listener and calling CSS animation APIs. And so it felt more like an appropriate tool for the job that I was trying to do, right? So if you hit a ceiling, right, what's the natural next step is that you want to use a tool that doesn't have a ceiling, right? It has a really high ceiling, or it doesn't have a low ceiling in terms of the UI. So this is kind of what I ended up doing, right? Writing UI code like this. And this is really cool because I have a pie chart here that's just rendering a slice. I'm iterating over an array of groups. I can set on click as a prop, and I can update my UI. So great fit for building something like this. Well, what's the problem? The problem is that the floor dropped out from under me, right? Those of us who started building apps in React, I did Backbone first, and then I did Ember for a long time, and then I did React. But all the front-end communities kind of have this similar problem, that when you leave a high-floor framework like a Laravel or a Rails, because you want to build a rich UI, that floor dropped out from under you. And so when you start out a new React app, that's the low floor that you're getting here. So you have a high ceiling because those frameworks fully embrace the DOM and JavaScript and CSS and HTML, but the floor drops under you. So now when you want to authenticate your users, how do you do it? Well, there's a million ways to do it. How do you want to connect to a database and model your data, send emails? All those are things that you now have to decide, and you have to basically reinvent the wheel on a lot of those areas. You don't get to take advantage of that high floor and start off your app kind of on the 10th level. So these front-end frameworks, I think of them as high ceiling, low floor. And this is kind of how I think about the last 10 years of development in web frameworks. On the left, we have the backend frameworks, which are traditionally high floor, low ceiling. And what have they been doing? They've been trying to raise the ceiling with tools like Turbo Links and Rails Turbo, Phoenix Live View, Laravel Livewire, even HTMX, right? HTMX is a library that's really well suited for kind of server-first frameworks. And these absolutely have raised the ceiling on what you can do before you have to leave those frameworks. And Ryan talked about inertia and some different ways that different technologies have tried to cross this boundary. But this is basically how I see their development over the last 10 years. And on the other side, we have the front-end frameworks, which are traditionally low floor, high ceiling, and they've been trying to raise the floor. So, Next.js came out and gave us get server-side props, which, again, is very minimal compared to the kind of rich modeling layer you get, database layer you get in something like Rails. But at least it gave you get server-side props, so all of our Next apps were using the same API to actually fetch data when a user navigated. And then more recently, we have Remix, which has added a lot of structuring conventions with things like actions and loaders. Again, trying to add more, fill in more of this part of the puzzle. And then even we have libraries like Prisma, which aren't tied to a specific framework, but again, trying to bring some conventions to the front-end folks. And more recently, RSC, which Ryan did a great job talking about how it's trying to cross this boundary and raise the floor of our front-end apps. So ultimately, both the front-end and the back-end communities are trying to build apps they're trying to build tools that have a high floor and a high ceiling, so that us as app developers, when we start a new app, we start on that 10th floor with out-of-the-box solutions for all the kinds of concerns we know we're going to all face over and over again. But we also don't have a low ceiling. We have a high ceiling, and we don't run into a situation where we have to say no to our boss or product person. Something is too hard to build. So this is ultimately what we want out of our tools. And I've spent a lot of time in both front-end and back-end communities, and I think sometimes we do talk past each other because of the way these things have evolved. And so this is what I mean by high floor, high ceiling. And you may be wondering, well, okay, what is the answer? Like, this is the problem that we're trying to solve, so what do we do about it? And the point of this talk is not to tell you what I think the right tool for this job is, because I think we don't know yet. I don't think either of these communities are going to stop innovating anytime soon. And so I don't know what it's going to look like going forward. But the purpose of this talk is to ask the question, how can we build frameworks that have both a high floor and a high ceiling? And what can we learn from the things that server communities have done well, back-end frameworks communities have done well, and what can we learn from the things that front-end frameworks have done well? So that's what I want to look at now. So let's take a look at back-end frameworks. And, if you've been on Twitter, and even over the past few years, server components came out, and some folks in the backend community were like, oh, React is learning how to send HTML to the browser, which, that's not really a charitable understanding of the technology. Server frameworks develop things, and front-end people in the front-end communities say, oh, they just don't want to stop using their old tools, they don't want to learn JavaScript, they don't care about user interfaces. I think both of these are not like steel manning the other side. So when I think about this problem, I always try to think about what's like the best understanding of why both frameworks are adding the tools they're adding. And so again, that's kind of the purpose of this talk. That's what I want to talk about. And so I'm going to start with the backend frameworks here, and I'm going to try to point out backend frameworks like Rails have tons of components. Yes, you can send an email, you can model your database, but I want to talk about kind of the principles that I believe are strengths of the backend frameworks that a lot of times the front-end community doesn't understand or misses out on. And sometimes people have never even spent time in these communities. So just to highlight a few, the first one is modeling. Now, when you start a new Rails app, you have this entire model layer called Active Record, and it does a ton of stuff. But one I just wanted to highlight here is association. So in Rails, if you had an author that had many books, this is how you would model it. And Rails makes assumptions about where your data is. There's conventions, and so it knows that you're going to have a table in your database called authors, and you're going to have a table called books. And because books belong to an author, the book is going to have an author_ID field on it. That's how it's going to link the foreign key to relate these two models. And that lets you do things like this, author.books.create. You can just access it using the ORM, or you can call author destroy, and it deletes all the books. So this is an ORM, right? But this modeling layer and this comprehension of the associations flows deeply throughout all of Rails. And it leads to some very cool things. Like on the left, there's an example of the form helper. So you can say, I'm going to render a form with a person, and a person has many addresses. So now I'm going to show all the form fields for my addresses. And because Rails knows that a person has many addresses, this is the only code you have to write to take that graph of data from the front end and create the graph of data and persist it in your database. So this is just one tiny example of how, by kind of putting a stake in the ground and Rails not being maximally flexible, right? They're not staying unopinionated. They're making opinions and saying, here's how we're going to model our data, and if everyone follows these conventions, this is what we get as a result. And again, it is pretty incredible how productive you can be if you just kind of play along and get to use all of this batteries included stuff. So I think a lot of front-end communities kind could benefit from having some more opinions, some more conventions, and it would lead to awesome abstractions like this. And yeah, secondly is just conventions, which I guess is kind of a larger part here. But again, the way these opinions flow throughout the entire framework and the APIs that they give you, the power of these APIs, is pretty incredible. So this is an example of creating a user, and up there we create the user with active record. And here we send an email with the user mailer because Rails has a mailer. And I can just pass my active record user model to my email. And I can deliver it later because Rails has background jobs built in. Over here, I have like a cron job. This is like a processing a video job. And it uses a queue. And I also have access to a video model here. And I can traverse the association graph, the graph of related objects, and see if the video's owner is premium or not, and then call one job or do the other. And then down here, I can perform it later on the last video in the database. Over here, I'm using something like a cron job to run this guest cleanup job in 1 week, and I can just set the wait duration, it's just like a timer, to 1 week and perform that. And Rails understands at every level all of these pieces, and they all work together, and as you can see, you get extremely expressive and powerful APIs. We really don't have anything like this in the front-end landscape, in any of the frameworks. There hasn't been a popular front-end framework that has kind of put a flag in the ground and made decisions like this that has led to these rich APIs. This is another example. It also has file uploads, and so a user can just have an avatar, and you can resize it. You just drop in a file input, and you save it. And you can configure the file uploader to use S3 or use another service, but Rails still has a boundary such that all Rails apps that upload files are going to look the same. So pretty powerful stuff. Here's another one. So this is a mailer that uses a user and then sends a summary in a cron job. So just one more example of that kind of the power of those conventions. This is one I just threw in actually because I was talking with Ryan after his talk, and something that comes up in React a lot is caching. Because we're doing partial page updates, how do you know when to refetch something? If you add an item to a cart over here, maybe you need to reduce it over here, or you need to update your total in a different part of the page. Caching is like a really important part of building SPAs and React apps, but it's also an important part of server-rendered apps. And you might want to avoid unnecessary trips to the database, or you might want to cache something so that you reduce some load for some public data. So Rails has this all built in. They have something called Russian doll caching, and here are my products from my database. And right here, I'm caching a product and then rendering this little partial. This is like a component. But this cache product line is going to render the component once, take the result, and then cache it in something like Redis. And then the next time, it'll just feed that out. And how does Rails know when it needs to regenerate the cache for this? Well, it knows what a product is. It knows which ID this product is in. So the cache key is based on the model name and the ID. And every Rails app, the only way you can mutate a product, so when we need to bust the cache when we either delete the product or update it, right? How do you do that? You do that using active records. So you would say product find one, and then set the name to this or set the stock to this. So you don't even have to tell it when to revalidate because, again, the conventions spread throughout all the components of Rails, giving us these really powerful APIs. And then the last thing I want to touch on here is testing. Testing is really, really big in the Rails community. I learned basically how to do test-driven development or even just testing at all from the Rails community. Sandy Metz is big on testing. Uncle Bob's big on testing. And the testing primitives in Rails are also incredible. I mean, out of the box, just from typing Rails new, you can write this kind of test right here where I'm visiting an articles path. I can click on a button that says new article. I can fill in the title and body, and I can create it, and then I can assert that it shows up. And that's going to be not just running against the UI, the HTML. This is making sure that the form data from the browser ends up in the database and is re-rendered, right? It's testing. It is you are writing one app and you are able to test the entire thing. And again, you don't have to figure this out and assemble this yourself. And if you've ever started a new React app and tried to get, a Cypress or a Playwright testing set up to work with whatever backend you're using, it's Firebase, but I'm using Auth0 for my authentic, it's a lot of work. And this is just what Rails developers get for free out of the box. So, and also, you can write a test here that asserts that after I've created an invite, that the correct email is enqueued onto my job system, onto my job queue, right? So I think this can all kind of be summarized by saying, I think the biggest thing that the front-end community is kind of not seeing the power of these back-end frameworks is this cohesion, right? And the cohesion that flows through all the components being opinionated enough that they work together, but not so restrictive that the community can't explore at all or experiment at all. DHH, who created Rails, talks about convention over configuration. And his point with that phrase was that we're all kind of redoing a lot of the same things every time we make a new app. We like to think we're unique and our app is a snowflake, but at the end of the day, we all need basically 99% of the same thing every time. So let's just make the decision as a convention so that we can hit the ground running, but then you can still have configuration. It's not convention and no ability to configure different parts. It's just that as a first step, make some opinions, layer them in, and that buys you a lot. So I think this is one of the best parts about kind of the current stack of back-end frameworks. So now let's talk about the strengths of front-end frameworks and things that I think the back-end communities don't fully understand the benefits of. And again, this is not about any specific, I keep saying React because I use React, but it's really for all the front-end frameworks and communities. I think one of the strongest things is locality of behavior, which you might be familiar with from Mr. Carson, and you also hear this called no spooky action at a distance. So what do I mean by this? Well, I think the front-end community really nailed this. This is an example from the homepage of Remix from our boy Ryan here, and this is a single file, and it loads projects from a database. It renders all of them with links, and it also renders a form that takes in a title and lets you create a new project. And the way you create the project is right here in this action function. So this is locality of behavior, right? Local reasoning. A lot of the back-end frameworks like Rails and Laravel rely on things like auto-loading and file name conventions. And while it's true that every Rails app uses the same convention, so if you know Rails, you can come into a Rails app and say, okay, I'm on the articles index HTML page, the view, so where's the data for that? Well, I know it's in the articles controller, so I have to go to controllers and art. The naming will always be the same, so there are conventions there, but it's still kind of like spooky action at a distance. There's still just a lot you have to hold in your head compared to something like this. If you just look at this, there is no spooky action at a distance. It is all happening right here. And again, I think the front end and the React community especially has really nailed this. And I've also heard from folks that I've worked with who are typically come from the back end frameworks that one of their favorite parts about using something like React is just that it's all in one file. They can split it out into two files when they need to, but they don't have to until they need to. So I think that locality of behavior is a really good one. Kind of following along the same lines here is lexical scope. So it's kind of the same point, but it's a little bit different. In Rails, you can render a partial, which kind of looks like a component. It's kind of something like a component. It's a chunk of reusable HTML. But the way you do it is like this. So you render a string menu, and then it says this will render a file named _menu.html.erb. So you just have to know that. There's nothing about the programming tools or the Ruby language that tells you that. That's just something that you have to learn as part of learning Rails. Whereas React embraces lexical scope. So why can I render a profile component right here in my gallery? Because it is available, it is defined, it is imported in lexical scope. And so all of the knowledge that we have around lexical scope in programming and all the tooling that our IDEs have for things like telling us you're trying to console log X, but X is undefined, all apply to rendering files and even more. We can also just create two components in the same file. You can't create two controllers in the same file in Ruby, even if you have two very small controllers, because of the conventions around autoloading. So I think lexical scope is a huge strength of the front-end ecosystem. Here's another example. This is not loading files, but this is how Rails gets data from a controller to a view. You set it as an instance variable. It would be like saying this.articles equals some data in JavaScript, so that it's available off of a this object. So in Rails, you fetch all the articles, you say @articles equals this, and then over in our view, you can reference that data. @article right here is this one. Again, kind of spooky action at a distance, right? It's just something you have to learn. The remix example I showed did a really good job of having everything local. But if you look at it, I didn't put it in the lexical scope section because frameworks like Remix and Next before server components, there's a little spooky action going on here, right? It is local because all the logic is here, but I actually don't call action or loader. Those are conventions from Remix. I think it's much, much nicer than what you see in Laravel or Rails because I can just look at this. But with server components, again, like Ryan showed, we really are taking this idea of locality, behavior, and lexical scope to the next level, such that when you look at a React server component, this database call this is running in our server, fetching the notes from the database, which it has access to because DB is in scope, and then it is rendering all of this, HTML. You can think of it as HTML. So how does it get the data from our database to our browser? Just with JavaScript variables, JavaScript scope. And even cooler, this is a server component, but it's actually importing expandable. And expandable is a client component. And how can the server component render expandable? Well, because it imported it. How does the server component pass data into expandable? Because this is a child right here. Whoops. This P note is a child. So this is actually an argument. It's passing data. It's children. But expandable, just like Ryan talked about, is using client. It's portaling to the browser so that when you click on this button, you can set some state and either conditionally show or hide the children. So how does it get in there? Well, it's just passing as a prop. It can pass props that are in scope, and expandable can use its prop, which is in scope. So this is pretty incredible stuff. We actually like lexical scope so much in React that we are shoving our API routes inside of JavaScript lexical scope. So here, this is a server action. We have a button. What happens when you click it? Well, why can you pass and create no action? Because it's in scope. But this is an API endpoint that's running on the server. And you can even import these actions in client components and pass them into forms and buttons. So all that to say that even though there's far fewer conventions in a typical React app, it's not going to be architected and structured the same way. One React app won't resemble another one the same way two Rails apps do. The power of this locality of behavior is incredible for understanding new apps that you walk into. Because there's no spooky action at a distance. So if I have to look at a page and understand everything that it's using, I can just look at the imports and follow the JavaScript scope rules, the rules of JavaScript, basically. So I think that's awesome. I think there's no reason that server-side frameworks couldn't do this. Rails could be just as a convention-focused framework, but let you rely more on Ruby scope and locality of behavior, and I think that would improve those frameworks a lot. And the final one here is really the big one. I mean, there could be a whole talk on this, but composition in React is kind of like the main point of the whole thing. So when I would render a chart in my Ruby apps, my Rails apps, it might look like this. Maybe there's a library I install, I render a bar chart, I'm passing some data in from Rails, and I get this. And again, they've done a lot to raise the ceiling, but the story usually doesn't go much beyond that. And you're going to hit a ceiling pretty quick. I want to customize some part of this. It's kind of hard to do that. Whereas in React, we have amazing patterns for composition. And maybe the default line chart looks like this, but if I want to do more, these libraries have thought how to compose all of these things so that they play together. And again, you don't hit that ceiling. You know, back in the day when I used Bootstrap, you can render a button. I mean, Bootstrap is awesome, but you hit the ceiling pretty quick. I mean, Bootstrap is great if you are building an app that looks like Bootstrap. I'm sure you can, folks can relate. If you need to change it and you start trying to override it, you're not going to have a good time. So there's not really much patterns for composition with Bootstrap. It's kind of all or nothing. Again, you're going to hit that ceiling pretty quick. Whereas I don't have to talk about the incredible patterns in libraries like Radix and React Aria that let you, bring in a drop-down menu with all the behavior, but complete flexibility in terms of styling and customization. You can even compose React components in really unexpected ways. This is a demo I built, and I'm animating a Radix toast component with Framer Motion. Those libraries didn't even know about each other when they were made. I mean, Radix didn't even exist when Framer Motion was created, and yet the boundaries are so good that I can use it to animate a Radix toast component. Again, even though those libraries have nothing, they don't know about each other at all. And that's very different from a lot of libraries in the ecosystem in the backend communities, that kind of unexpected serendipitous composition and new behavior that emerges, it just doesn't happen quite as much. So I think the big thing that front-end frameworks have given us is composability. I think that's their biggest strength. And so this is basically kind of where we're at today. I think server frameworks are very cohesive, and that gives us incredible abstractions in them and makes developers very powerful, very powerful without having to learn a lot of stuff. One thing that DHH talks about that I really like is this idea of conceptual compression. And he sees his job as the author of Rails basically to compress more of the concepts that are needed to make a modern web app that looks good and can send emails, can sign up users, can create data. When I learned Symfony and then I switched to Rails, and I did Rails for 4 or 5 years, I didn't know jack. I mean, I didn't know what I was doing at all, but I could do incredible things just by following the guides. And that's the other part about these frameworks, is that if you want to ask a question how to model some data or do something, you can just go to the guides. It's the Rails guides, and that's very powerful. Again, where as compared to the front-end frameworks, you're not going to have a guide page that's going to tell you how to model doctors and patients as a has-many-through relationship. That's a pretty complicated thing, but active model is really powerful, and again, every Rails developer is going to be on the same page about that. So I think this cohesion is the best part of server frameworks. I think composability is the best part of UI frameworks, and today this is kind of what it looks like. But I think there's no reason that both of these communities, which are going to keep developing, and I don't think there's any silver bullet. I think we're going to have lots of different communities. Some are going to be having started from the server side, some from the client, and they're going to keep working on their abstractions to close this gap. But there's no reason that both of those communities can't embrace both of these principles and hopefully give us frameworks that let us start on a high floor and have a high ceiling in our web apps. So that's my talk. Thank you.
That was really good. That was really good.
Thanks, man.
Man, that was awesome. I actually had a boss, Shane Sizer. Did anyone work with Shane? Yeah, we got a couple people. I know, at least you, Lance. He always used to tell me 2011, 2012, like convention over configuration. And I never really understood that, like largely growing up in a C world is where I kind of came from, which means I only had broken dreams. And then going to JavaScript in 2011, which means I only had broken dreams. And so this idea of convention over configuration never really landed until I tried Webpack. And then I understood what configuration was. And so now it's like seeing this makes a lot of sense. I really like this idea. Why aren't we doing this more often, people? It's crazy, come on. The next person coming up is Adrian. He's gonna talk about a technology that I think is genuinely super exciting. And I think a lot of people can take away from this and be very excited about building pretty robust apps with Go.
All right.
Thanks. It's gonna be great, man. Very.
All right. Let's go. It works. Great. Hello, everybody, and thanks for having me. I'm here to talk about Temple, which is an open source project that I build. It's a way of building front ends in the Go programming language. So I guess why would you want to do server-side rendered stuff in Go? Well, I work on a lot of commercial stuff, mostly retail bits and pieces, high volume, like insurance sales, those kinds of things. And you tend to need like static pages for search engine optimization. I also work on some government things, and in the UK, there's a design sort of set of guidelines called GDS, which talks about making sure that your applications run without JavaScript running on the client side. That's because in some cases, it might be virus scanners that disable it. It may be network issues. There may be things that are outside of a user's control that prevent them from using script. So there's a few reasons why you might want to have a fairly traditional web app. You might also just not have the skills in your team. You've got to go back end and you want to do a little bit of front end and just enough to keep your application going. So there might be a sort of learning curve argument as well. And also, if you're rendering something on the screen, you're going to be waiting for that API anyway. Are you really getting much benefit from firing up an SPA just so that you can display like a loading animation? Maybe not. So if you're going to do this in Go, what do you actually need? Some sort of templating library that feels familiar, something that's kind of easy to pick up and use. Good developer experience, something that sort of doesn't make you hate your life when you're using it, and a bit of an ecosystem around it so that it's not just you're not hand cranking everything yourself. So Go ships with the standard library, so the usual response is, why would you not just use the stuff that's built in? And the reason is that it fails in weird ways. So if you're not familiar with the Go templating system, this one here fails when you start your program because you can't call arbitrary functions in a Go template. You have to pass in a function map, and then so you'd have to pass in toUpper into your function map in order to use it. So that's a significant source of friction. And this one here fails at runtime when you try and render the template. And that's because there's no price field, but because Go's built-in templates are only rendered at sort of execution time, you can't see that until you try it out later. So it fails in front of your customers, which is possibly the worst time for it to happen. And the developer experience isn't really what you'd expect. If you've ever done React, it doesn't feel like good. Yeah, so if I'm old enough to have done the sort of rounded corners pixel tricks and all the rest of it, and old enough to have used Razor Pages when they came out in 2011. And that had all the kind of mod cons, IntelliSense, and like the auto-completion, syntax highlighting back in 2011, right? So if I'm going to say to a team, hey, we're going to use this Go templating, but it's kind of like stuff that like you did in 1998, it's not going to feel great to people. And if you use JSX, then again, you'll have been really familiar with that kind of tooling, that kind of style. And this is, again, a transpile thing. You write your TSX or JSX, and it gets turned into JavaScript and executed. So if you're familiar with JSX, and Temple isn't going to look like a million miles away. Originally, rather than trying to build something new, what I tried to do is work with the existing tools that were there. And try and add auto-completion and all the good stuff into it. But the design of the tools that were available at the time, they weren't really built around this concept of type safety from the get-go, and didn't have sort of annotations. So I ended up having to build something to sort of scratch the itch, if you will. So what you've got here is this Temple code here gets compiled into Go code and bundled as part of your application. You can define a Temple component by writing this Temple syntax here with parameters and interpolate variables into the result. You can then use that, compose those components together with this @symbol syntax, and you can insert sort of standard functions and normal controls flow into your HTML components. And then you can render them to standard out, so you can get data, pass it into your components, and then render it out to a target writer. So the kind of typical workflow then is create a new Go project with this Go mod in it, install the Temple command line tool, create a Temple file, generate Go from that template, which takes a few milliseconds, and then run it. And you get out a Go file that looks a bit like this. So it's really straightforward. All it's doing is writing straight to that IO writer. And that means that the result of it is pretty fast, right? Who cares about a few nanoseconds here or there? But, you shouldn't have any concerns about the performance of that. But the benefit of the compilation step is that you get compile time errors, right? So if you're trying to use a field that doesn't exist, it's going to break before it gets to your customers, not in front of your customers. But who wants to wait for that, right? Who wants to wait for the compilation? Obviously, not me. I want to have a language server. I want to have red squiggly underlines in my editor. So I built a language server, an LSP, a language server protocol server that ships with Temple, and a VS Code extension to go along with it. VS Code is the most popular tool used by Go programmers to build Go. But there's also NeoVim, because we're not animals. And there's even a Golang plugin as well, which is a little bit less advanced because JetBrains only recently added the language server protocol support into the tooling. But yeah, there's all the kind of editor support that you might expect. In the background, the reason that I'm able to do that as one person with another co-maintainer is because I piggyback on top of the rest of the Go tooling. So Go already ships with a language server protocol. So what I do is pass the Temple file and then remap the positions of the Go code within it to the actual generated Go code, pass the information through to Go please, and then I can map it all the way back. And so that means that you get pretty much all of the features of the Go language server, just in your templating language. Recent innovation is live reload as well. So we're compiling this stuff, right? And when you compile a Go program, you make a binary and then you run that binary. So if you make changes to your template, surely you would have to recompile your Go binary and restart your process, restart your web server, right? Not in this case. If you go into watch mode in Temple, it watches all the files in the background, and it generates code in a developer mode that reads all of the HTML strings from a file on disk. So that means you can reload in the browser automatically without having to recompile your application for those. It's only if you change your Go code within your templates that it needs to do the restart. And this process here handles it. There's also a proxy thing here, so it introduces a server-sent event to reload the browser, because who can be bothered to press Control-R? Life's too short. So the center of Temple is this concept of the temple.component interface. So in Go, when you define an interface, you can implement that interface implicitly. So anything that has a render function on it that takes a context and a writer and returns an error, anything that has that function signature automatically implements Temple component, and that makes it really useful for plugging in other components of the ecosystem, which you'll see in a second. So this thing here, the Temple component, produces some code that implements the temple.component interface. But you can also implement it in code. So you can, here I've defined a button. It's got a field on it called text. And then I can implement the render function. Now, obviously, you're on your own here in terms of content escaping. So any kind of cross-site scripting kind of problems and stuff, that's up to you to solve in a code-only component. In a normal Temple component, all of the content is auto-escaped for you. And then, yeah, you can render out your code component, and you can compose that like you would any other Temple component. You can also compress that down into a sort of more anonymous function. So if you don't want to define a type, you can define this Temple component func, and that just turns a function into something that implements the interface. As you might expect, you can compose templates together. So you can define a left, middle, and a right, and then show them all together in one go. The Temple component interface takes this writer, this io.writer, and in the Go programming language, pretty much there's lots of things that implement the io.writer interface. One of them is files, and the other one is HTTP responses. So if you want to sort of use Temple to generate static files, you can create a file on disk and then just call the render function on the component. And this is one of the kind of first use cases that I had for Temple, is working at an insurance company, making really complicated insurance documentation for tens of thousands of people every day. And so you want to have there are tens of thousands of documents every day. And these documents contain so many fields. And any kind of issues with the template where you weren't seeing the right data could be sort of reportable to, what's the right word, the Financial Conduct Authority and stuff. So we were really careful on getting the documentation right. And so using Temple and having these extra compile time checks was really helpful for us. Of course, you can use it in HTTP server, right? So here's the longhand version of it. You call your component, so get this temple.component, and then temple ships with a thing called temple.handler, which does a few niceties around HTTP responses, making sure that if the template rendering fails for some reason, that it returns the correct status code and stuff like that. But essentially, it turns your temple component into a HTTP handler in Go. So you can boil that down to a single line there. So if you've got like a temple component, it doesn't take much effort to turn that into a web page. And obviously, you probably want to host some static content because we're here at HTMX Conf, I guess, so you probably want to include HTMX. In the Docker side of things, you can host temple. It's just because you're just building a Go binary, you can host it anywhere that you can host Go, right? There's no special thing about this thing. So you can use Docker, and the usual way is like a multi-stage build, where you have one stage that does the build, so it has like the compiler and all the other stuff, and then a runtime image. And the runtime image is slimmed down, so it doesn't have any of the tools and stuff. So that's really useful for reducing the number of vulnerabilities that get discovered in images over time when you ship them to your cloud provider. But I'm tight. I don't like to spend money, so I like to use Lambda for things that are sort of hobbies or smaller things, or in fact for commercial projects as well. And so you can, typically with Lambda, you have to implement this thing called a Lambda handler, but Go has an adapter that you can use. So you can create a standard HTTP handler out of a temple component, and then you can use a Lambda adapter just to convert that into a Lambda function handler. And the performance of Go on Lambda is really excellent, and you can use the ARM64 ones to save a little bit more on your CPU costs as well. Static content with Lambda is a bit of a pain because typically it's quite expensive to do large responses with Lambda. So typically people introduce like a CloudFront and route some stuff to an S3 bucket and stuff. So it gets a bit complicated. But there's an example repo there's an example in the Temple repo full with CDK and all the rest of it that you need to do that. So what does it look like with HTMX? I hear you all ask. Well, it's in the Go world, we don't have anything so really opinionated, right, as Rails, right? Go is quite resistant to that as a community. So you're probably going to see some things where you think, well, that's a lot of code, right? But it's very simple code, and it's very easy to understand. And I think that's one of the things that I really enjoy about Go is that you can get somebody who's never touched it before, and they feel pretty familiar with it, and they're using it effectively in a couple of weeks, and it's easy to learn. In sharp contrast, I guess, to some of the onboarding experiences I've had where you're bringing in lots of developers who are learning TypeScript, and they're coming from other languages, and it's such a flexible language that everybody writes it in a sort of different way that sort of represents their background. So cohesion as a team can be quite challenging. So here's a view in Temple. We're receiving a list of, or slice it's called in Go, of users. And we're going to put a link in to add. And because I'm lazy, I've put in the HX boost there. And that's a feature of HTMX that turns what would be a full page refresh of that page into a partial refresh of just the active content. If there's no users, print new users, or just display the users, and that's just iterating for a normal for loop and displaying the users out there. So Go, to implement a HTTP handler in Go, you have to implement this serve HTTP function on your code. So it's like part of the HTTP handler interface. So typically I divide it up into a get and post or whatever verbs I'm using. So the get request is all it's doing is grabbing some data from the database and shoving it into the template and rendering the results. Very straightforward in terms of implementation. The add page is a little bit more complicated because we're going to have to receive some form data from the client side, right? So usual practice of that would be to create a model to hold that data that you're going to receive from the form post. And you might apply some validation to it. So if you're creating a new item, you might want to sort of do some validation and say, well, this is an invalid email address or something. So let's have some functions on it that provide validation. And then here's our add view. It's got a form. We're using the HX boost again. It's going to post towards that users/add endpoint. And then we can start implementing straightforward, labels and fields and stuff like that. And if you start doing this a lot, I'll show in a couple of slides how to build up your own component libraries and stuff like that. Because obviously this is kind of a bit boilerplatey. You might get a bit frustrated with that over time. So then we're just rendering out the forms, and then if there's an error, displaying it to the user, or just displaying the validation messages. And again, we're making use of this sort of the ability to compose temple components into sections with this validation messages. The handler is a little bit more complicated for add. We've got two verbs, get and post. So in the case of get, we're just displaying the form and saying, okay, just display the initial, don't have any validation messages because the form isn't dirty yet. And then we've got this display function, which is, again, like you've seen before, we're calling this handler, which just takes the view and renders it out for you. The post is a bit more complicated because we've got to pass the form that we've just received in from the client. And then we can use Gorilla's schema library to map the fields that we got from the HTTP form post onto the struct, which if you're familiar with classes from other programming languages, like you're just copying the data from the post straight into the form. At that point, you can run the validation functions and kick the user back out to show the validation and exit early. Or if there's no validation errors, you can try and save the entity to the database. And if it fails, because your database is overloaded, you can display an error. And then if everything's okay, redirect the user back. So pretty traditional kind of MVC style thing with a little bit of HTMX magic to make it not feel terrible. And that's a kind of low-cost way of building things. Now, React isn't going anywhere though, right? Like, it's useful. There are lots of like client-side components that you want. I think we saw some great examples of things like graphs, right? Those are really useful. And so you can interact with it. You can create React components, that's no problem, and then attach them into your client, pass data from your server side into the client side. So all you want to do is kind of attach things. So here's a basic component, and here's a function where you pass an element and it mounts that React component in. But using the Alpine style thing of you can put JSON into attributes of your elements and then load them into your React side. And so that's a way for you to pass data in a fairly straightforward way from your server side into React components that might be running on the client side without having to build like APIs and start fetching back and forth and adding that extra complexity. And you can build that with AS Build, which is really fast, so you don't get into sort of massive build cycles. And so, yeah, then the passing data to React bit inside Temple is straightforward. You create a Temple component, which has this data dash, whatever it is, attribute on it. And then you can grab that information and mount the component by looking at the closest div element and mounting that in. So there's a way for you to, you're not locked in. If you start going down this route of using Temple, you're not like, oh God, I'll never get out of this thing. You can plug in like other things in the ecosystem. And that means other Go templating libraries as well. So if you want to use something from the standard library, there's like this one here, there's a Temple function that turns that straight into a Temple component. So you can pick up the standard library. And there's this other thing called components, which takes a totally different approach. Instead of creating a weird DSL like I did, they just did it in Go code, which is probably more sensible. But it looks a little bit strange, but you can convert that into a Temple component and render it and use it and compose it just like everything else. So again, you can make use of the wider ecosystem. And if you want to build your own component libraries, it's just a standard Go package. So it's the same process for sharing like any Go code that you want to share with somebody else. There's nothing special about Temple components. You can just create them. So you create a new Git repo, create a module inside it, import Temple, write your component. Now in Go, if you want to expose something as public, you just start the function name with a capital letter. And so if you create something like Temple hello, generate the file, commit it, and push it, that's it. You've created a reusable component library that's available on the internet. And then you can import it with a single line there. You import the file, get it, and you can then use it within your own projects as well. So it's relatively straightforward to build these things and share them around. And people have started, like people I don't know, have started building up component libraries. Like this one, Go Press, is going to be launched soon. It looks pretty impressive. And there's some other kind of components that people are building. So I'm hoping to see some interesting components get developed over time. So a couple of things that we've added recently to Temple is a playground. So this runs in WebAssembly in the browser. So you can try out Temple without actually having Go installed on your computer. If that offends you in some way, you can try that. Also added this thing called rendering once. So sometimes you want something to only be rendered once to the page like each HTTP request. So there's this thing called a once handle, and then you can wrap children around in this once handle. So if you want to sort of do something like render a script to the screen to the page, you can do it, and it only gets rendered once, even though you're using the component multiple times. So that's a way for you to sort of load in dependencies and bits and pieces. And then what am I working on? Automatic Go imports. So here I've used FMT, but it hasn't brought it in. That's really annoying, because when you press save, it'd be really helpful if it just brought it in automatically. So that's coming soon. And people have asked for HTML LSP. So this is one of the things that I didn't know what I was missing out on, because I've never seen this, right? But it turns out that a lot of people, if they use VS Code, are used to having this HTML auto completion inside, but you don't actually get it in JSX, and so I'd never actually seen it. So I'm working on a way of mapping through to other language service providers, LSPs, sorry, language service protocols, and bringing back the results from them so that you can kind of enrich it, so you can use things like the Tailwind LSP and other things inside, like all together at once. And then another thing I'm working on is streaming responses. I have a good POC of this. So one of the nice things about Go is its ability to do multi-threaded workloads. And one of the ways you can do it is with this thing called a channel, which is a bit like an in-memory queue. So you can iterate over a channel. So you might do something like run a Go routine in the background to fetch some data from the database and then stream it back through to your template. So you can kind of start rendering out some HTML and then in the loop flush out parts of your response back to the browser. So that'll be coming soon. So yeah, like why should you bother doing this? Well, Project Health, thanks to Prime and Carson, the project's had a little bit of attention, I think I would say. And so thanks for that. And so it's maintained by me and a friend of mine, Joe. But I think stars are cool and everything, but contributors is what really matters. I think, for the long-term health. So we've got like over 100 contributors now to the project, which I think is good. I feel like it's sustainable, and I'm going to try and make sure that it doesn't become unsustainable as a project. Like it's got to be like it's no good if I start hating doing it, right? Or my wife says, "Please stop." So yeah, that's what's going on with it. There's an online community. There's docs@temple.guide if you're interested in it. The Go community has a Slack channel. There's a Temple channel in there if you want to ask questions and stuff like that, or just bring up on GitHub discussions. And obviously, there's people on YouTube who make stuff with it, and they've got like examples of doing stuff, and there's Reddit as well. People talk about Temple on Reddit. It's quite strange the first time it happened. It's like, oh, people are talking about this, and it's like, I don't know them. But so that's it in it. I think, I'm not sure how we are for time, actually. Do we have time for questions? If not, I'll have to see you at the pub. Oh, yeah, let's say one question. Has anyone got a question? Maybe not. A question over there. Does it have a formatter? Yes, it does. When you, like, I'm pedantic about it. I wanted it to be as batteries included. I'm trying to keep it so that there's no config file either, because that just increases the space of the weird configuration problems that could happen. Yeah. So the question was, does it have a formatter? Yes, it does have a formatter. All right. I think that's it then, folks. Thanks for having me. All right.
Hey, absolutely
Thanks, man.
love Temple,
Cheers.
man. Absolutely love it. And that was cool, huh? Yeah. I told you that. Yeah, I told you it was really cool. I like Temple. Yeah, Temple's amazing. Have you tried Temple? Anyone? Gophers? Do we have some gophers? We're kind of gopher heavy on this side. What's going on over here? Like, okay, we got a hand up maybe? If you haven't, like one of the things, since not a lot of people tried Go, and you saw the Temple LSP that he would compile the things, parse it, and then send it over to the Go LSP and all that, you gotta remember that Go's fast, and so you can't actually even tell all those things are happening. It feels fluid and all that. And so if you're thinking like Rust style, that would take like minutes. This is like, microseconds. It's very, very fantastic. Yeah. So we actually have, this is gonna be a little bit hard. Where's I see Big React over there. Right? There's Big React Industrial Complex over there. We are having an apostasy of the React community come on stage today, and I know this is not an HTMX conference, But we actually have someone coming in, Anthony, to come talk to us about actually making rich web applications with HTMX. You're gonna kill it. You're gonna do great.
Hello, people. Okay. I'm pretty audible. Can you still hear me now? Okay. Did that work? Weird. What's going on here? Okay. So we've had a lot of very lovely talks today. I mean, we had Ryan talk about things from the React side. We had Sam talk about things from the backend side. And I want to talk about things, I guess, from the Y Combinator news or Hacker news and the Reddit comments side. But just especially that browsers have come a long way. So we've built up a lot of these myths as an industry that once upon a time might have been correct, but over time things get better, but the popular conception doesn't change. So yeah, let's jump in. I'm a bit jet lagged. I came in from Berlin, so even though I know it's like 4 p.m., my body doesn't know. So just bear with me. So my name is Anthony. I'm the co-founder of a company called API Toolkit. I'm more on it in a bit. I'm on Twitter, and I try to write a little bit on Medium. And yeah, so API Toolkit is an API observability platform. And why API observability? It's mainly because most observability platforms focus on your platforms and error rates and things like that. And we believe that if we analyze the actual API payloads, we can catch a lot of bugs and catch a lot of breaking changes and things like that. And because of its nature, there's a lot of data. We have to render a lot of charts. Basically, the kind of applications you would expect to build in like React or something, something very, something like that. And yeah, we decided to build this with Haskell and HTMX and Hyperscript, the H3 stack, which everyone should be using. And there was a lot of learnings, and one of the learnings is basically what this talk is about. The other learnings is, yeah, we really underestimate browsers, but let's just jump in. So jumping straight to the first myth. And this myth is very common. I see people mention this a lot as rebuttals when things like HTMX and the rest come up. They say, the app just can't be very interactive because you have to download all this JavaScript and CSS every time you perform an action. And I think in an online conversation recently on Twitter, there was this kind of comparisons of the Hey email client versus Google Mail. And one of the arguments was basically this. You look at the network tab, and in Hey, or in Gmail, when the app loads, maybe we download 5 megabytes of JSON, of JavaScript, while for Hey, the first download would be, I don't know, a few kilobytes. But with every action, you're downloading the same files over and over again. So this is a very popular myth. And it is kind of true. And so this is API Toolkit. And I just recorded with caching disabled. When you click on the same link, it takes, I recorded this yesterday on a Starbucks Wi-Fi, so bear with the speeds here, but it would take 3 seconds to load this page on that Starbucks Wi-Fi and download 2 megabytes of data. So back to that myth, there are quite a few solutions actually. There is, HTMX Boost. There is also libraries like PJAX that came out in the last years. I think Ryan even mentioned PJAX in his talk. There's Turbo Links from the Rails world. And what these libraries try to do is that when you click a link, when you want to navigate somewhere else, they hijack that request, with JavaScript, then make an AJAX call to the server, get the file, and stitch it back into the DOM. And by doing this, we don't have to download the same HTML, the same CSS, JavaScript that were downloaded already and in the head. Maybe the ones in the body would still be downloaded, but that kind of solves things a little bit. We didn't do this mainly because, there's some benefits you get when you just let the browser do its thing. For example, you can trust the state a little bit and just initialize things when the DOM loads. But when you use this kind of techniques, it becomes tricky when to initialize things. Although we use this, for example, on like the documentation website, for example. But there's another solution, which I'm quite surprised that this is not more popular. I think this is very popular in the React ecosystem because a lot of people want to build these very interactive PWS, progressive web apps that run offline, that are very smooth. So they are more aware of service workers. And the whole point of this bit is that service workers can actually be used if you're building multi-page applications as well. What is a service worker? It's just a bunch of JavaScript that when the user makes a request on the page, it goes to this. Can you hear me now? Sweet. So this service worker intercepts all the requests that are happening and then decides what to do with that request. For example, go to the network or save it from cache, and that's here. Or go to the network and then put it into the cache. And there's a lot of things we can do with this. For example, this is that same screen, but this time we have that cache, that service worker cache enabled. And we see that instead of 3 seconds to load this page, it's 400 milliseconds, and that's because we only have to load the active, the bit of HTML that this page actually needs, and everything else is just handled from cache, like you would see here, that a lot of things are just from memory cache and disk cache. Where's my mouse cursor? Oh, sorry. So how do you do this? It's pretty simple. You write a service worker JavaScript file, and that's all. Okay, not very simple. I think most people do not want to write a service worker.js file. I've never written it by hand, but every time I look at one, it's just a lot of stuff going on in there. But there's a library from Google called Workbox, and I'm also not sure why this is not more popular, but you basically write a configuration file, a JavaScript file that looks like this, where you specify a directory. And what it does is that it reads all the files in that directory and pre-caches them. But beyond the files that you have locally, you can also configure something called runtime caching, where you give it a URL regex mask, and any requests that match that regex would get handled by whatever strategy you decide. And I use 2 strategies here. So one is stale while we validate, and that means when the user makes a request in the browser, we're going to handle that request from the local cache, and then immediately we handle it from the local cache, the browser automatically goes over the network to get the latest version of that file in order to just replace what was in the cache. So you always get, maybe not the latest version, but you get maybe one version old in some sense, which is enough most of the time. Of course, there are other caching strategies like this cache first, which means if the file is in the cache, we just handle it from the cache and move on. And with this config, it will generate a service worker file, which you can, I don't know, call from your HTML. And now a lot of your requests would actually be handled from the cache, and so they would be pretty fast. When you've installed the service worker, you would see it within the browser's console, like what you see here. So you can update it, unregister it, etc. Okay. There's one more solution, and when Nate and Jan gave their talks, they were talking about this whole latency problem. That you want your app to be pretty smooth. You don't want, when a user clicks something, you want to just respond instantly. You don't even want to wait for that 400 milliseconds, for example. And there are many solutions to this. For example, there's this HTMX preload JavaScript extension that you can use. But this functionality is part of the browser specification already. So just like how browsers support service workers without you using React or anything, they also support this using something called speculation rules. And what that looks like is that you create a script tag in your HTML file, and you add this bit of JSON JavaScript thing where you can tell the browser that, okay, here, for example, that any href that matches whatever you put in here, it can be a regex mask. We should prefetch those requests, and then you can specify an eagerness. For example, immediate just means immediately the browser loads, the page loads, and the browser comes across this speculation file. Just make the request, prefetch it, and just keep it and wait until the user actually clicks on that. Eager means, eager is pretty much the same as immediate. But moderate means when the user hovers on the link. So if a user hovers on it, then we immediately start to make that request. And conservative means, you need to already start doing this mouse down, for example. So you can decide whether to prefetch without already rendering it, or you can pre-render, which means immediately the user performs that action. The next transition will be instant because you're just swapping already rendered page, the already rendered page right into the browser. Okay. So this is just a small video showing, without pre-render, we have to hit the network, render it, and swap it in. But with pre-render, I'm pretty sure you didn't see anything happen because there's nothing that happens. It's already available. My mouse always gets missing. Okay, whatever. So the second myth is, I think we also spoke about it today. Someone was, I think Warren was showing an example of how you would have this offline applications that sync. So it's a common use case that you want your app to operate offline, or maybe it's a network-heavy application, but if there's no internet at the moment, maybe we try that request, we try to sync when the internet comes. This is one very common reason why a lot of people go to build single-page applications, because they don't believe that this is possible otherwise. But it's actually very possible. So using that same service worker approach that we looked at before, but this time we have to write a little bit of JavaScript. So this is not an anti-JavaScript talk. So we still have that workbox config, .js that we looked at before, but we create a new JavaScript file where we use a workbox plugin called bgsync, background sync, where we've basically told it to retry the requests for 24 hours. And here is a regex mask. And what this means is that any post request that matches this URL we will try to handle it through the network. But if there is no internet, if the network request failed, then this plugin is going to get triggered. And that means it's just going to be queued in here, and it will keep retrying until internet comes, or or this max retention time is reached. We can also write something called a catch handler, which is if there is no internet at all, what should we do? And it's a bunch of JavaScript that you conditionally can do anything. For example, you can return a pre-cached file, HTML, an endpoint, whatever. Or you can look into the requests, see the route, see the headers, and then maybe it's an endpoint that was expecting JSON. You can build the JSON and return the JSON in here. So you have offline capable apps in, I would say, like 10 lines of code compared to Warren's 30-something lines of code. And this would work, in any application. It's just HTML and a service worker that works everywhere. So the third myth is that multi-page apps would always flash white when you transition between pages. So this used to be the case, actually. So I don't know if I can call this a myth because it was true. It's still true, but it was more true in the past than now. And why it's not so true anymore is that browsers, since 2019, have supported a feature called paint withholding, or paint holding. And what that means, I'll hit play first, then you see. So you can see without the paint holding, we would usually flash white while the browser is rendering the next page. But with paint holding, I hit play again. With paint holding, the browser makes the network request, but doesn't start rendering it until the request is ready, like all the data it needs is available. So we don't necessarily flash white anymore, or if there is a flash white, it's super instant, And so yeah, it's a myth that is not so true anymore, but a lot of people don't seem to even notice. The only time you really see this flash white now is if you're making requests that are cross-origin. But for same origin, you don't, the paint holding just kicks in. Okay. I'm just catching my breath for a bit. So the fourth myth that I want to talk about is that these fancy cross-document transitions are not possible. And I actually blame Google for this, because some years back, they had these demos in, was it a Google I/O or something, where they showed these very fancy transitions between pages in like e-commerce applications, and everyone wanted to do it. And obviously, you can't really do that, especially at the time, without using JavaScript to hijack and control the entire routing and all of that. So this was true until a few years ago, but it's no longer true because browsers now support something called the View Transition API. And this is an example with this View Transition API. So you click on a page, and the next page, comes in with a very fancy animation. And this is something you would not expect to do by rendering some Rails application with regular HTML templates, no JavaScript, nothing. But it is possible. At the moment, it's only possible in Chrome and Edge, but soon it would be on the other browsers as well. And we can do it with just CSS. I mean, there's some new, where is this mouse again? Okay. So you can do it with, there's this, I don't remember what it's called in CSS, but there's one that represents the page you're transitioning from, and then one that represents the page you're transitioning to, and you can, animate and twin and do whatever you want to do between them. So now your regular old legacy multi-page application is looking very sexy, and things are animating in, things are working offline, things are instant. One more myth that I want to mention here is that people believe that every action, like if you're using something like HTMX or live view or one of these options, or just writing multi-page apps, that you have to be completely locked into that paradigm. So you have to send every single thing to the server, do everything in the server, and get a response. I know we saw the Flappy Bird example, which is that pushed to the limit. But I mean, we all know I hope we all know that you can actually write some JavaScript. In this example from still API Toolkit, I guess. So we have this component here. Where's the mouse again? But we have this search bar thing where you can dynamically build all these queries. And we could have said, oh yeah, since we were really all in on HTMX and all this stuff, let's, I don't know, see how far we can push that limit. Or we could just write a web component and put it in there, and that's what we did. So there's a filter element web component, and it works. It's pretty much like any other HTML element. We can access whatever state is in there, and but the rest of the process is regular form submissions with HTMX in this case. Just sending whatever is in that component with the rest of the form. So everything else like the time picker, all of that are just regular HTML form elements. Okay. The final myth for today. So it's that operating on the DOM is slow, and that the client-side code we're going to write would be spaghetti. And this is not very wrong. I mean, the DOM is not the fastest. And also, I think a lot of people are just burnt from the jQuery days. I mean, we all had our fair share of spaghetti. I don't have much rebuttals to this. I mean, what's wrong with that? When we used to write jQuery-heavy apps, we used to ship things pretty fast. So, I mean, maybe someone else is going to maintain it and cry, but... but also, it's not very true, because when people think about multi-page apps that want to have a lot of interactivity, they imagine that, we're just going to write a lot of this manual JavaScript sprinkled all around the application, and which is why it's going to be, spaghetti. But more and more, we can do a lot more with just CSS and HTML. And I'm usually pretty shocked at how little JavaScript I write, to be honest. Because a lot of, let's see if I can show some. Yeah. Because a lot of interactions, for example, we click on this link, it expands. There's no JavaScript involved there. It's a checkbox. And based on the state of that checkbox, we just decide whether to display the element below or not. So a lot of things that before you would use jQuery, on click, add hidden class to this element, all that stuff, we really don't need to do that, which means you can focus on writing JavaScript for the really big problems that, like that web components thing we saw. And one pattern that I use here. Where's this mouse again? So one pattern that I use here, I think there's some code later that I will show. Let's see. Yeah, is that with HTMX, so we use the checkbox thing and tailwind CSS to drive that state. So when based on the state of the checkbox, this class, this peer log item thing is basically tailwind CSS magic. I'm trying to find. So it's basically tailwind CSS magic, and we can conditionally apply CSS based on that state. For example, when it's checked, peer checked, we're going to add this block, tailwind CSS block class to the div below. And so no JavaScript involved. And then with HTMX, I can now use this hx trigger and hx get to make the request to the server and get that data, and of course, override the content of this div. Yeah, this is really nice because if you noticed on this video, when we expand it, it loads super fast. It loads, and I cheated because I clicked it the first time and I clicked it again. With this pattern of using hx trigger intersect, the intersect happens once, so the data has been queried from the browser and it's already available. So now you're just showing and hiding it based on the checkbox. And yeah, a very interactive log explorer experience without any line of JavaScript in sight. Of course, except the JavaScript in HTMX. So the browser has come a very long way. And when people are making this argument, I think like today we're looking at, we saw this chart that showed where the server is right now and how it's trying to raise the bar. And we saw the chart of where the client-side frameworks are and how they're trying to, I guess, raise the ceiling or raise the floor. But the browser has been on its own corner, just trying to, I don't know, make both of them work better together or make both of them irrelevant. I don't know which one. And people are not looking closely at what is happening in the browser world. And I think if we do, there's a space for the very interactive single-page application frameworks. And I mean, they're very important. I mean, we still use web components in here, which came out of that movement. But if we leverage what the browser is really good at doing, for the 95% of applications, we can use the Rails and use the whatever backend frameworks we have and get very, very close to these experiences that our end users are looking for, without, for example, jumping into the SPA bandwagon, for example. So thank you.
I want to say one thing, which is that things that are myths when Anthony is building web apps are true when I'm building web apps. So I think that's an unbelievable talk, but that's the way I build apps. They've got flashes and jumping and all that stuff. So very, very cool. Very cool.
Thank you. It is true. So yeah, thank you.
Do you want to MC?
No, I'm good.
Come on.
Thank you.
That was awesome, man.
Thanks, man.
All right, well, we're kind of coming to the end of the day, which is pretty awesome, I guess. Are you guys excited for the after party? Yeah? Yeah? I don't see any clapping. Where's the clapping? Nope. All right. Oh, yes, we got a clap. Let's go. All right, so we do have one more guest. Pretty good-looking guy. I'm a pretty big fan of him. I'd like to welcome to the stage Prime. Wait, no. Wait, you're going? Yeah, one more time. I thought it was my turn. Oh, I'm so sorry. Dude, that was my fault. Oh, my gosh. I didn't even check the schedule. Boo that man. Who is he? Kenny. Oh, my goodness, Kenny. Come on, Kenny. I feel so bad. It's because I wore white today. I'm just totally off. It just feels all wrong. Hey, sorry about that.
You're all good.
He has a briefcase. He's way better than me. Trust me.
Good afternoon, everyone. I need just a second to get going here. It's a long afternoon. If you want to stretch it out, you're not going to hurt my feelings. Let's see. We have an HTMI somewhere. Oh, where's the adapter at? Thank you. Quick show of hands, how many of you guys have heard of Montana Cadastral? Just so I know. How many use it ever? Okay, maybe I should do a little show and tell. Okay. Perfect. Well, good afternoon, everyone. My name is Kenny Kettner. I'm the Information Products Lead at the Montana State Library. And I'm thrilled that they left my stuffy institutional talk for the end of the day after all of these exciting talks. So I've definitely learned a lot today, and I really appreciate all the other presenters. But I'm here to talk to you today about Montana Cadastral. And I've given a variation of this talk to a GIS audience and to a library audience, and I thought I should give a talk, if possible, to a programmer audience. And the app is newly released in April and flying without a net, i.e. no more old application as of May 1st. So I'm trying to hit the road and let the people know. So let's talk about Montana Cadastral. What is Montana Cadastral? Excuse me. So Cadastral refers to tax information. It's basically real estate information, boundaries, and so forth, along with who owns it. So we have an application that we put out called Montana Cadastral. It includes the owner information, the geospatial boundaries, statewide boundaries, topo. You can browse the map and click around on different properties, or you can search by 6 different methods. You can print some reports. We've had, I believe, the first statewide cadastral for any state in the nation, released way back in 1999. Yeah, and more about that in an upcoming slide. The previous version of the app was launched in 2012, so definitely got a little long in the tooth. And we were due for a new one. And if you want to play along at home or on your phone, it's at gis.mt.gov or cadastral.mt.gov. So why do we need a new one? Again, the legacy application was quite dated at this point. We didn't have modern architecture of any kind on there, really, and didn't look good on mobile at all. And internally, we'd been preparing for a new one. We tried to make a new one ourselves with the Esri's Web App Builder product. People who have heard of Esri, the company, yeah, I know you have. They're basically like the Adobe of maps, if you want to think of them that way. They kind of dominate the industry. And our users wanted more. Of course, mobile friendly was a constant demand. They wanted different imagery so they could look at different years of their property. And there were some kind of tricky cases like with condominiums, trailer parks, that sort of thing, and troubles printing. So all that is addressed in the new version, which does everything the old version does. It's based on the Esri Experience Builder product, which is React-based, but we don't have to hold that against them. The application includes PDF property reports for both single and multiple properties. Allows you to select multiple properties, which the old one didn't. As I mentioned, better handling of kind of those multi-owner properties. Very cool swipe tool where you can set 2 base maps and swipe back and forth between them. So say you want to look at a 2005 aerial photo and a 2021 aerial photo and see what changed, you can do that. And behind the scenes, which is kind of the focus of this talk, easier for us to maintain and improve and part of a modern repository situation. So on to the development. Well, actually, I guess let's take a quick peek at the app. I hate doing this live, but I feel like just a quick, world's quickest tour. Of course, the disclaimer. Oh dear, you can't even see that. Okay, let's not. Left is an exercise for the reader. Okay. So the data, unfortunately, is not our data. It's Department of Revenue's data. They have the Orion database, which is an Oracle product. And that's all the owner information is stored there. They've written a data service to query the database. Not really what we need. We wanted a modern API that returns JSON that we can work with more easily. So we worked with our friends at Department of Administration to create this API last year. And they also host the application since it's a multi-agency thing. And at the library, we're sort of the GIS clearinghouse for the state of Montana. We have 15 statewide layers that we maintain, as well as a bunch of other stuff. We're going to have statewide LiDAR imminently, I would say within a year. So it's logical for us to maintain the cadastral web mapping theme and also the application. So back to the timeline a little bit. Again, 99 was the very first one based on map objects IMS. The previous version was version 2 of the Esri JavaScript API, now known as the ArcGIS API for JavaScript for some reason. Base map was in Esri Managed Services and maintained by us, updated monthly. In 2019 onward, we also released a product called Cadastral Beta based on Esri's web app builder. It was never feature complete, so kind of got scrapped in favor of this new one. Also, web app builder retires next year, so not really tenable to move to that. The new app is based on Experience Builder, and the application support web mapping services are hosted in ArcGIS Online. So why Experience Builder? It's supposed to be their low-code, no-code platform. The idea being that for the purely GIS aspects of the application, we could hand that off to one of our GIS analysts. Say we need to add a new base map. You know, an analyst can do that. You don't need a developer to do that. And also, we don't want to, you know, have it stuck in one hand only, i.e. just mine. That would be bad as well. So it's actually a really good product in my opinion. It does make pretty looking web applications, and it's part of our general effort to move more services to the cloud where possible. Continuing, it allows you to create custom themes and widgets. We invested some resources in developing an Experience Builder template for our application, so we can make use of that. We have half a dozen or so custom widgets in the project, the search, selection tools, and property information being some of the big examples. And we managed to squeeze React PDF in there for the reports. One of our requirements too was to have a directly linkable property details page. So if you know the geocode and optionally the tax year, you can get right to it without having to fuss with the rest of the application. And Redux is used to maintain state between components. Okay, talking a little bit about the DevOps. In the old days, we were a Subversion shop, and we had multiple repositories for the old Cadastral, and unfortunately, including an incomplete code base, some stuff that couldn't be recompiled. So therefore, had to be kind of treated as a black box and limited docs on that. So now we're in a much better place using Git. State of Montana uses GitLab for their solution there, and Podman rather than Docker, but a similar product. Again, hosted by our partners at Department of Administration. We have a development, test, and production. In our statement of work with the vendor, Langen Engineering, who provided some of the slides on this, we included a development guide and some coaching. And Langen was selected because they had an innovative build process for Experience Builder, which I will get into. So the traditional idea with Experience Builder Developer Edition is it's a separate install for each developer. You have to install Node, you have to install Experience Builder, you set up your own authentication, register your application, and then run the server and the client both on your local development machine. And of course, this leads to, you know, getting out of sync type of problems pretty quickly. It's not very collaborative and lots of manual copying involved. And this diagram from our friends at Langen kind of sums it up. You've got your application and your widget code, and then you're just doing it all on your local machine and pushing it to a web server. So can we improve on this? Yes. So enter docker/podman. So the idea is we set up the development environment once, including the sign-in configuration info for ArcGIS Online. So the developers will basically spin up their own experience builder from the container and do their work, and then goes in the repository, which will automatically build and deploy for us as well. So for our actual setup, this is what it looks like. We code and create the app and experience builder. The custom widgets, of course, you still use your favorite IDE of choice to make those, but everything else, you want to try and keep it within the experience builder interface as much as possible so that you don't accidentally break something. And when the developer spins that up, makes their changes, push to dev, which is our main branch, the GitLab will automatically build and deploy it to the dev site, and then we can repeat that for test and production as we merge those. Couple of interesting things to point out. It actually downloads a fresh copy of Experience Builder each time you build it, and kind of handles that for you so the developer doesn't have to bother with all that configuration on their machine. Okay. Couple of post-launch lessons as well. I'll kind of talk through that faster than I expected. So we did have an outage early in May when we were republishing a map service. If you knew any realtors or surveyors around that time, they might have been a little grumpier than usual. So this was caused by a failed publication of that data service, and it hosed our whole organization for the day. So we very quickly replaced the service with a view, so in the future we can just publish the new service and then point the view at it rather than having to delete the existing one and publish the old one. So probably should have done that sooner. But anyway, this required a significant configuration change in the app, but users didn't get that until they cleared their cache, and this is where we discovered that normally Experience Builder increments the CDN folder every time you build it, but because it was containerized, every build was the first build. So it wasn't doing that. So it kind of came around to bite us, but our solution, which worked, was to put today's date with a random number after it on the CDN folder, and that way it's guaranteed to be different and the browser will fetch it. So sometimes those clever browsers come around to get us. We've also kind of identified that our API is a little slow. This is the one developed with Department of Administration, which we will inherit eventually, so maybe we can end up solving it. But for now, we are minimizing the API calls for the property information in an attempt to address this. And we're going to work on quantifying which methods are accessed the most and have the most performance issues. So a quick look at the future, and then I think we'll have time to play with the app after this, actually. So maybe once I get out of presenter mode. So we've engaged with Langen through the end of this calendar year to do enhancements. And after that, the state library will be adding new widgets and base maps. We've had a feedback survey on there, which we'll leave up. It was a little rough during the time when we were down, so letting your users comment anonymously in a survey is a kind of a double-edged sword. And in terms of technical debt, things we need to keep up with, we've done our best to kind of minimize that liability. So we got to keep up with Experience Builder, of course, and React PDF. And we have to keep up with any changes from Department of Revenue and ITSD, that's the Department of Administration. And then any configuration changes related to our pending cloud migration. And we have some other applications that we'd like to link to a little more thoroughly. Cadastral is quite popular, so we'd like to draw attention to some of our other products as well. So quick thank yous to Langen, Esri, DOR, DOA, and the State Library, and of course our users. So let me exit the presenter view and see if this now will let me, yeah, now we're cooking. Okay. Yeah, as you can, this is our Google Analytics on the site, so 106 users in the last 30 minutes, not bad for a Saturday, but as you can see, quite predictable traffic with the weekday. Our mapping services and Esri get 120,000 or so requests per day. And okay, here we go. Let's have a quick peek at the application. The disclaimer, of course, this is just meant as a convenience for the public. It's not a legally binding anything, nor is it suitable for engineering purposes. Kind of use at your own risk. So I'll just zoom the map on something. Get our property information, which loads on the left. Yeah, cool. You get the general summary. These are expandable, collapsible, of course. And then you can also look at owners, appraisals, market lands, all these other features. 6 different search options available to you. Generally, they are by county, and that's because the data service from Department of Revenue is by county, so we're limited there. Owner, geocode, address, subdivision, assessment code, certificate of survey. Most people just need owner and address. Let's see. If you want to just download the raw data, which if you're a company like Onyx, good to see them here, by the way. I know they're heavy users of our data. You can download the whole state or individual counties. If you want to correct your owner information in Cadastral or request that it not be shown, DOR has a form for that. And yeah, we also have a pretty good user guide, including animations that shows you how to use it. And a feedback page. If you want to leave me something nice instead of a random slur, that would be great. Some of the tools we built on the map, of course, we've added the full screen ability, which people have asked for. We have various quick zoom options. You can zoom to a township, range, and section. You can zoom to a county, zoom to a city, zoom to a reservation. Our base map gallery, this is one big reason we needed an upgrade, is the old one only had 3 base map options. So let's say NAPE 2013. This is aerial imagery that's flown for the country. We'll do NAPE 21 here. And of course you can toggle between the two. I guess I didn't get that set right. And if we enable the swipe tool, you can, this is what I was talking about, you can swipe back and forth and kind of make a comparison. I think a lot of people will like that. And then of course you can print the map. Our PDF reports for a single property are up here. And then if you have multiple properties, for example, if we zoom in, oh, I've got to turn the swipe tool off, I think. Yeah. We zoom in a little bit. We've got the multi-parcel selections down here. So you can make, say, a rectangle
It'll number them for you. And you can also print a report, up here that will include all of those, along with clickable links to the properties. So we're pretty happy with it. Of course, always welcoming feedback. So again, if you have any, use the feedback form on the site. And are there any questions? Yes, sir. The question was about water rights and hunting rights, which are two kind of common use cases for the application, as like a starting point to answer those questions. We do have conservation easements in there, so you can tell if there's one of those. Hunting rights, that's where you need to contact the property owner, so you could use Cadastral in that way, and a lot of people do. Or, again, our friends at Onyx make a product that's good for that too. Other questions? Okay. Thank you, everybody. Appreciate it.
All right. You definitely are handsome. I meant that when I said that earlier.
Yeah.
I want you to know that. I would never just say something about myself like that. This is wild. Hey, we have one more guest. I hear they're really handsome. You're going to do great. I'm committed to this joke. Oh, yeah, hey. Oh, thank you very much. Hey. Hey, hi, everybody. I don't know if you know me, but my name, at least on the internet, is the Primagen, which is kind of a strange name. You'll notice that I won't probably plug this in. It's Linux. I don't really actually want to do that. I think it's going to be very difficult. Plus, I have audio skill issues, life skill issues, video skill issues. I have all the skill issues in one. So instead, I thought I'd kind of tell like 4 stories. Small stories, don't worry, they won't be too long. I know you guys want the after party, you want this to end, you can't wait to go hang out, but just hold on, let's get through this. So, did you know that I was born in Billings, Montana? Yeah, I know, this is like, I love Montana, super happy. I know, clap for Billings, good job, Billings, you got that. And my mom, gosh, she was so good at it. Did you know I came out in 16 minutes? This is way too much information, but hey, 16 minutes. I'm the fastest born baby in the West, definitely. Anyway, so, life wasn't always fantastic growing up in Billings, being in Bozeman, kind of going back and forth and all that. When I graduated high school, I didn't really know who I was. 2.16 GPA, anyone lower? Okay, 1, 2, 3, 4. Okay, that's hey, I'm a 1%er. It's just not not the side you want to be on in this one. But, so I had a lot of trouble, and I'm sure some people are familiar with the story, but I went from my renegade youth into a less renegade youth, and as I kind of transitioned from an old life into a new life, I had this desire to go back to school, to be successful. And when I went, I failed out of pre-calculus, which is, it's not even calculus, it's like baby calculus, and I still failed out of it. And so it actually took me, I took it again. And when I took it again, I barely scraped by. And I was sitting there thinking I used to be so smart at math, and it was so easy in high school. I never even did a day of homework, and my GPA reflected that, and it was just so easy. But now it's I can't even do the easy, what should be the easy stuff, because it's not even the hard stuff like calculus. And so I took summer school, and during summer school, I would have 2 hours of math a day. Then I'd do 2 hours at the learning center for math. Then I'd go home and do 4 to 6 hours of just practicing calculus, because I really wanted to, I wanted to pass, and I was so nervous about not passing and all that. And then I ended up going from what I would consider probably the worst student there to the best in the school for differential equations by the time I was done through all of it. So I was went from the worst to the best. And this is not a flex story. It's not meant to be a flex story. Just wait for it. Okay, weird flex, bro. Nice, you're good at differential calculus. While you adjust pixels on the screen, cool. Anyways, but I tell you that story for a reason, because in 2011, I got hired at Schedulisti. I tried to start my own company, lost a lot of money, and lived in a place really close to campus where some guy threatened to kill me. So, well, you know, we're just starting to get into our real life. Things are getting better. I'm now making $50,000 a year, thinking it's the greatest moment of my lifetime. It's just so awesome. I have health insurance, sort of. Like, it's just great. And during that, this was 2011. Remember, there's no Grunt or Gulp or Webpack didn't exist. Imagine how great those days are and how horrible those days were, right? And so they asked me, hey, we can't seem to load. We have really low White House scores. How do we get our page faster? So I'm like, well, probably network requests, right? Like, that's your standard problem. So I've never done that before. I had no idea, and so I built a compiler in Java. Java, compile once, debug everywhere, right? And crazy, right? 2011, I wrote Java. And so that was kind of like this weird moment in life where I've never even seen this problem. I didn't even do web programming. I was kind of doing web programming in PHP, so this was very unusual. I didn't know what I was doing. And I tell that story to tell the next story, which was in 2012, I got hired at Workiva, well, it was web filings back then. And web filings. And during that time, they were building like their tax app, but in HTML5 and JavaScript and all that. So it was like brand new, everything was super cool. And they're like, all right, we need the iPad 2 to be able to like pan and zoom and drag and all that kind of stuff. Can you build that? I've never built any of those things before. I don't know about panning and zooming and all this kind of stuff. And I just quit Schedulisty. I'm getting kind of nervous. You know, things like this is a very hard problem. But after some amount of time, things were conquered. We had a zooming and panning and all that kind of app. And then fast forward again, I'm at Netflix. And when I got to Netflix, I was able to kind of join a team, and my manager said, hey, we're gonna do this really big test. We're gonna actually integrate with Facebook. You're gonna be able to request stuff from your friends. You'll be able to send them like movie recommendations and all this kind of stuff. And I was pretty excited about the project. That sounds really good. But he said, hey, who wants to do the server side? And nobody said they wanted to do it. And I was like, well, okay, I'll do this. And so it took like 9 months of writing all sorts of stuff, crazy bugs, including some things would only show up past 7 p.m. in California. And they'd stop showing at 7 a.m. on the East Coast. Really weird things were happening. It was very, very difficult to like understand why this would happen. And it took a long, long time to get that stuff done. And at the end of it, my boss pulled me aside and said, if I would have put anyone else on the team or in our org, I don't think it would have got done. And the reason why I tell you all those stories is because, man, when I was like starting to go to school, I was so nervous that I was like smart enough. Right? And I think a lot of people, I hear it all the time, people talk about imposter syndrome, like, hey, I don't actually fit in, I'm like faking it till I'm making it, but I don't know if I'm gonna make it. You know, it's not very much, it's just faking it, it feels really weird. And it was during that time doing calculus, which is like such an inconsequential thing for the rest of my life, that I learned something very important. If I can endure a lot of pain being just time learning, because really raw learning when you don't know what you're doing is painful. You don't know what you're doing, you have to bang your head, you have to ask for help, you have to do it hour after hour after hour after hour until you finally get it. And then when you get it, it just seems so trivial. It's kind of weird how that works. But I would never have kind of discovered those things without calculus. And so kind of the point of all those stories were every one of those points, nobody else wanted to do that work, because that work was really, really hard. And I didn't think I could do that work either. But remembering just one success and knowing that if I can have just enough time, I can kind of like muscle it and make it work. It's like a really hard thing to believe in yourself, but think about when you learned, who here knows recursion? I assume everyone knew recursion. Was it easy to learn recursion? No, it was crazy, right? Like why would you keep calling a function? What's the point? Then they give you like, oh, just sum some numbers. And you're like, this is really dumb. I'd write a for loop. I don't get recursion. Why would you use recursion? This doesn't make any sense. And then you walk a tree and you go, that's why recursion is really useful. I now understand why recursion is great. And so it's like learning these really hard things in life. And if you can just remember what it felt like volunteer for the hard things. When no one else wants to do it because it's going to just benefit you so much. There's an Uncle Bob tweet, which you can't see on the screen, but he says something along the lines of, let me just open it in Chrome really quickly, hold on. I know, luckily I have the internet already on, so this will make it easy. But he says, I know we talked about Uncle Bob, I think twice today, unusual to have him come up in any of these type of conferences, but here we are. So he says, never let your employer lead your career. Learn things that your employer will need next year and lead your employer to them. And so like, I guarantee you there's at least some portion of you out there that don't actually think you could do some set of things. Like, okay, that's reserved for these really smart whatever people. I'm just a regular worker. I can just do this. I'm good at the UI. I couldn't do all those things. Like A, yes you can, and B, your career will thank you, your life will thank you, your kids, if you have kids, will thank you in the future because you did something that was hard or impossible in your view, but actually, when you look back, it was trivial. It was actually trivial. So that's like challenge to you is please take the time and do something way out of the comfort zone. Build Flappy Bird in HTMX. Like do something ridiculous, right? John, yeah, there you go, Nate. You know, like do it because it's wild and it probably shouldn't be done. And you're not building it because you want to make people build Flappy Bird in HTMX. You're doing it because you want to see where bounds are. How hard can you actually go? And trust me, you can go way further than you think. And that's all I want to say. That's it. Good luck, everybody. I think we have some closing remarks. I think so. I think Nate is going to come up here and have some closing remarks. I know that was rather short. I wasn't planning on going long. Don't. Not doing an encore.
Let's give a round of applause to the primagen for being an amazing MC today.
And our next speaker, Apollo. Hey, thanks, buddy.
Hey guys, I'm Nicholas Oxford. Some of you might know me as Apollo today on Twitter. After today, I think I'm gonna switch it to my real name, but it's been kind of weird. First of all, thank you guys for coming. You know, it was like 6-8 months ago, I was sitting at a happy hour and some guy was like, do you know what HTMX is? I was like, yes, very well. And they pointed over to Carson. I was like, wait, that's HTMX? But I started talking to Carson, and I shared this idea with Carson. The original idea for this conference was HTMX first remix. I'm like a remix, bun, JavaScript, hype beast. I'm on the front end, you know, the edge of the stuff, but I also understand HTMX. It's super important, and I love seeing the arguments online. So that was the original idea. Carson was all about it, and he told me, if you put this conference on, you can have my book for free. So my entire motivation for this conference is a free book. But seriously, I really appreciate you guys coming. I know, I can't believe over 180 people bought tickets. This has been a crazy week, but I'm super excited. Now on to the fun stuff. We have a after party at Shine Brewing at 6 p.m. Please don't show up before 6, like show up at 5:50. If you bring your card, your first drink is free. We'll give you a token. So sorry about last night, but tonight you get a free drink. That's pretty awesome. Yeah, that's it. Big Sky DEF CON 2024. We'll be back next year. Thank you. Oh, what's this? Oh, sure.
I've got one more thing. Hold on. I got to get all set up now. There we go. One more thing. So we here at HTMX Incorporated Limited Esquire, we believe in pushing the boundaries of what is possible. Not crazy like these guys, but pushing the boundaries of what is, whoa, that didn't mean for that to happen, of what is possible with hypermedia. And so I know a lot of you have been at night talking with your families about this, and with your girlfriends when your wife isn't around, boyfriend, whatever. Okay. But pushing hypermedia forward is serious business, and I think that what I'm excited to announce at this conference, as sort of a walk-off for it, is that HTMX 2.0 is available in Golden Master starting like right now. So you can go to your local software shop and you can purchase HTMX on either hard disk or floppy disk. So we have hard disks available and we have floppy disks available. Tried to work something out with Radio Shack. Really hard to find software shops to sell this stuff these days. But yeah, HTMX is going to be available exclusively on floppy disk for the next week. And then we might distribute it some other ways as well. So I wanted to give the first official copy of HTMX to the guy who's the reason why you've all heard of HTMX. And so I'd like to present this honorary first HTMX 2.0 Golden Master hard disk to Prime. So thank you, buddy. Thank you, buddy.
Thanks.
Perfect. And believe it or not, that bag I've been dragging around has a bunch of disks. So if you really want an actual floppy disk with and it really has HTMX 2.0 on it. I'm not joking. I'll be up here and you can come up and grab one. All right. Thank you, everybody. Really appreciate it. Great conference.
Nice.
Thank you, Nick. Thank you, Prime. Thank you, everybody who made it happen. Thank you. Photo. Oh, photo. Yeah, we're doing a photo. What are we doing the photo of? Everyone up here?
Yeah. So we're going to do a quick, we're going to do 2 photos real quickly. We're going to do a speaker of the photos, and we're going to do a full group photo. And we're just going to kind of come around here, right? I would say let's bring everyone up here first to do everyone and then just speaker. So everyone come on up. Let's get a group photo.